Okay, I think that did it.
Awesome.
Well, hello everybody, and welcome to another exciting episode of Paleontologizing. I've got Laurdee with me today again.
Hi everybody, I'm Laurdee from Cooking with Laurdee. Usually I'm doing cooking content, but today I am touring the museum with my friend Danny.
We are here at the Museum of Ancient Life in Lehi, Utah. Should be a really cool, exciting stream today. You may recall, if you've been here for a while, and if you've been following me on this road trip thus far, that this is the same museum where my encoder overheated and died, so we had to stop halfway through, that stream ended prematurely. We hadn't even gone through the Jurassic period into the Cretaceous when that happened. So today, we're going to do the whole museum and into the Cretaceous. It's going to be pretty cool. So,
let's do it.
Here, let me see if I can get this attached to here. Hang on, everybody, just a minute. I'm trying to get this.
Do you want me to hold it?
Yeah, can you hold that for a second? Thank you. I feel like this will give me some peace of mind if this is connected to here.
Sorry guys, one moment.
There we go, much better. Okay, cool. So you'll see behind us, we have a lovely Gorgosaurus skeleton cast. This is a tyrannosaur from the Campanian epoch, the late Cretaceous period. And, kind of funny in that it's chasing these little Othnielia, these little ornithopods. These are not contemporaneous. These dinosaurs did not live neither the same time or the same place. Othnielia is actually from the late Jurassic period, so from a long time before Gorgosaurus. I don't know. I guess I probably didn't consult any paleontologists for this part of the museum, but this is just the main entrance here.
Timber is asking, isn't most of the Museum of Ancient Life casts?
Oh yeah, almost all of these are going to be casts. There's a few genuine fossils on display. We've got the holotype of Supersaurus, actually, which I'm really excited to show you. It's going to be pretty cool, but almost all the rest of this is casts. This is much more of a kind of public-facing... There's a lot of families who come here and bring their kids. It's maybe more on the spectacle side of things. There's a lot of dinosaurs here, and they're mostly casts and sculpts and replicas and that kind of thing. But there are some genuine fossils, too, that we're going to check out. It's going to be really neat. Speaking of sculpts, check out that big pterosaur up above me right there. It's a big Asdarchid, probably supposed to be Quetzalcoatlus. That is about the right size for the wingspan, maybe? But probably a little bit too robust in the body and everything. You want to walk up there to this top and get a closer look before we go into the main part of the museum? And then we've got a big Schifactinus fish up there too. Pretty neat. Everybody's favorite giant predatory fish from the Western Interior Seaway. Check that out. Look at that right there. Look at that, Laurdee.
Whoa.
Look at those teeth.
Oh my gosh.
Yeah. So, this is a giant fish that lived in the Cretaceous period in the Western Interior Seaway. So this was swimming around at the same time as elasmosaurs and mosasaurs. And that weirdo flightless bird that we saw at Museum of the Rockies. With the almost wingless bird. These fishes may have actually eaten those birds. It's portrayed that way in a lot of popular media, at least. And then up there, check out that Quetzalcoatlus. We should really go up those steps and take a look. But pretty cool. The largest animals to ever fly are the pterosaurs. And Asdarchid pterosaurs might have been the largest. But yeah. Look at that. Just the size of a small airplane. No big deal. Just a flying reptile. Bigger than a Cessna. Pretty neat. Mayor Space says, has anybody ever calculated the heaviest laser gun that Quetzalcoatlus could carry? You know, I've never actually seen that in a literature, Mayor Space. It sounds like it might be an interesting, like, master's thesis or something. But yeah, there's really not too much that we know about Asdarchid pterosaurs like this. Most of them are been pretty fragmentary. You know, these are animals that have really, really thin, delicate bones, so they don't fossilize particularly well. This one right here, it looks like a lot of the elements are too thick and too robust. I don't think their bodies are actually that big. I think their body is roughly the size of, like, my body. Their head is certainly much bigger than their body. But yeah, pretty cool.
Do pterosaurs have feathers?
They did. Well,
Proto-feathers?
maybe. That's an excellent question. Whoever asked that. Did pterosaurs have feathers? That was you. Oh. Well, excellent question, Lord.
Thank you.
Yes.
Thank you.
So pterosaurs had what we call pycnofibers, like little hairs. Mm-hmm. And we've known about these since before we knew about feathers on dinosaurs. And so it's always like, oh yeah, pterosaurs had some sort of weird hairy covering, and like, who knows where they got it. Or like, you know, it's just like aberrant that an archosaur would have hair, essentially. Mm-hmm. It might be homologous to feathers, though. It might be that that's like the same structure.
Uh-huh.
So pterosaurs are not dinosaurs, as you
Right.
know, but they did evolve from the same ancestors as the dinosaurs. So maybe that ancestor had like proto-feathers, and then pterosaurs inherited that, and dinosaurs did too. We still don't know. It could be that that feathers are like a basal, like ornithodyryn archosaur trait or something. We don't know yet.
Huh.
Yeah, further work is necessary. Check out that skull. That is so neat. Yeah. Pretty cool animal. Pretty cool animal. All right, what do you say we go ahead and go on into the actual museum? Cool. Hey, Dave in accounting, how you doing? All right, we got our hand stamps here. Now let's go ahead and go on in. So speaking of pterosaurs, we've got a number of them right over here. We do, yeah. Thanks. Exhibit hall.
But the paleontology field isn't narrow to what we understand. On the contrary, we stretch our understanding to try and take in the universe.
Yeah. Fashion murals. This is neat.
It's Urca.
Let's protect our
Turn one.
If they're removed.
Oh, it's Urca.
American
Thank you
Loop.
so much for the sub. I really
Correct.
appreciate that.
It's
Thanks
Urca,
for your
just
support.
subscribe.
Man, this is so nice that it's so quiet in here right now. We may have picked like the perfect time to come in.
Awesome.
Yeah. We're showing everybody this. This is kind of cool. You want to play around with this, Lurdy?
Oh, wow. Okay, so I turn it and it's 1 year.
1 year. And so this spins 10 times faster than this. This is 10 years.
Right. 100
And then 100
later.
years is spinning 1/10 the speed of that.
You can't really see this one
Yeah.
move.
1,000 years spinning.
Just barely.
Yep.
This one you definitely can't see move.
Yeah, that would be 1,000,000 years would be 1/1000th of.
Yeah.
Yeah, there's 10,000.
Oh, there's
and there's
10,000.
100,000 and then a million.
Wow.
Yeah.
That's
But really cool.
cool.
I mean, that's gear ratios right there and deep time. What a neat exhibit. Pretty cool. And then is this isn't a touch screen, is it? It is. Well, in theory. Pretty cool. Just trying to give you a sense of time as you come in here through the museum. You got to get in the right mindset to be able to appreciate everything that you're about to see. This idea of deep time, the idea of fossils being the preserved remains of ancient life. When you're designing exhibits like this for the public, you got to lay the groundwork, before you show them all the, before you really wow them with the dinosaurs. Here, we've got another viewing lab right over here, like we saw yesterday at the Utah Museum of Natural History. This is a pretty big facility. Got that big roll-up door right there, another one over there. Lordy, when I was here in, it would have been like early 2018, they had the Utah Raptor block here.
Oh.
Which was, have I talked to you about the Utah Raptor block? And it's this great big block. It's like the size of a small truck, maybe. I don't know. It's about the size of like the new Volkswagen Beetle.
Okay.
It's just this big block, big rock block with all of these Utah Raptor elements in it. All these Utah Raptor all seem to have maybe gotten stuck, mired in a pit or something like that. And so there's all these different individuals all in the same spot, from full-grown adults to like tiny, tiny babies. There's the maxilla, so like the upper jawbone, like that big, like the size of a pencil eraser from a Utah Raptor. It was amazing. And they were holding it here, and I was visiting, and somebody saw me like in the lab, and they came out to talk to me, and like brought us into the lab and got to see it, got to touch the Utah Raptor block. It was really cool.
What are the tubes from the ceiling? Asks Dylan.
Those look like their dust collection. Yeah. So, as you might imagine, in a facility like this, you deal with a lot of dust, and so that is to suck up the dust. I'm sure it goes through another tube and probably into like a big compactor. Usually there's like a whole closet devoted to that, like a big thing that like shakes and then compacts the dust, and eventually you can remove the dust. But yeah, it's it can be kind of a health hazard. I've never actually worked in a lab that had like real proper dust collection, so it's cool to see this. We saw that yesterday too at the museum in Salt Lake.
They're currently working on Barosaurus.
Yeah, Barosaurus. And here's a Barosaurus cervical vert right there. This is one of the neck vertebrae. I think we might see some Barosaurus later. And Supersaurus might even be the same thing as Barosaurus. I think the jury's still kind of out on that. But right over there is a skeletal drawing, what we call a skeletal. It's kind of the shorthand for that, of Barosaurus. And the bones in red are the ones that are represented here in the lab. Pretty cool. You can see there's the caudals right there, the tail vertebrae. You can see highlighted in red on the skeletal. There they are there.
Would a scientist activate the tube, or is it normally always on?
I think you have to turn it on. It depends. But in this case, this sort of thing uses a lot of juice. Like, it needs a lot of electricity, so you don't want to keep it on all the time. You want to conserve that.
And Slayer, Utah Raptor is from Utah.
Yeah, Utah Raptor is from Utah, absolutely. Hence the name, yeah.
What do they do with the compacted dust?
Probably throw it out. I don't know. Maybe they give it to a gardener or something to be used in mulch or fertilizer or something like that. I don't know. Yeah.
I don't know.
We always
just a good question.
At UCMP, yeah, we at the museum in Berkeley, we would just throw it out. Yeah. But the compactor there didn't always work. There's a Utah Raptor leg over there. Against the far, on top of that metal cabinet, there's an Allosaurus skull in black, and then just to the left of that is a Utah Raptor right hind limb. You can see how robust that is compared to other dromaeosaurs like Deinonychus or Velociraptor. Yeah, pretty cool. Pretty cool. Here's some more Barosaurus material. Man, sauropods, man, they are such a pain to dig up and to get back to the lab and then to clean and then to store. Everything about sauropods is a pain because they are huge. Once again, here is a beautiful sauropod leg right there. This is probably a Apatosaurus.
10 months.
Looks pretty robust. Just the femur is like almost as tall as I am. Kind of nuts. Yeah.
Relic Wolf just sold for 10 months.
Holy cow, Relic Wolf, thank you very much. I appreciate your support. Thank you. That's awesome. Yeah. Oh, and this is really cool. I said we weren't going to see too many real fossils at this museum, but this is one of those. This is exceptionally rare. A juvenile Ceratosaurus from Bone Cabin Quarry, Wyoming. This is probably a commercial specimen. This was probably like purchased or donated to the museum. There's an ilium, upper hip bone, and scapula, shoulder blade. Maybe from the same specimen. but just a skull like this is really, really rare. You're looking at the left side of the skull right here. So it's missing a whole bunch of the bones, obviously. This is just basically the left side. You've got the dentary, cerangular, lacrimals, nasals, maxilla, premax, a bunch of the bones in the back of the skull. But really, really cool. And look at, so Ceratosaurus is that same dinosaur, Lordy, that you were looking at. It has the little nasal horn.
Oh, yeah.
Look at how much smaller it is on the juvenile there.
Oh, ontogeny.
Ontogeny, exactly, yeah. Yeah, pretty cool, pretty cool. And this is neat. I didn't see this last time. I've got a little video about prep work or something. Pretty neat. How can you tell if you found a fossil? You like that?
Yeah.
Yeah. A heart-shaped rock is not a fossil heart, and a smooth round rock is not an eyeball. Yes, this is true. Soft parts don't fossilize like that. Even when they do, they don't look like you would expect them to. Yeah. Yeah. And this is cool. Curator's picks of our collection. Got some Spinosaur teeth from Morocco. Whether or not those are from Spinosaurus is another question. There's something weird going on with North African Spinosaurs in the early Cretaceous. Yeah. But pretty cool, pretty cool. And then, oh, this is really neat. I didn't even look at this last time. But this banner right here is really instructive. So, we talk a lot about the Mesozoic era on this channel, but that's just the tiniest slice of Earth history. The Precambrian is a time long, long before the dinosaurs or mammals or anything else. You're looking at actual scale right there. Like the Precambrian is super, super long. Yeah. I guess in this case that would include the Hadean and the Archean and all of those eons as well. But anyway, the age of dinosaurs is in green up there. The Paleozoic, the time before the dinosaurs, is in blue. And then the Cenozoic, the age of the mammals, is just that little yellow sliver. But those are proportional, according to the amount of time that they span. That's... Yeah. So in the grand scheme of things, dinosaurs didn't really live that long ago if you consider the entire history of the Earth. So yeah. And hey, Mr. Ichthion, how you doing? Good to see you. Over here, we've got a nice display of taxidermied paleontologists. I made that joke last time too. Yeah. I always used to joke too that when I die someday, I want to be put in a museum like this. Just stuff me and put me in one of these displays that shows this is how paleontologists work in the field. I don't know a lot about the history of this museum. I think most of the displays look pretty modern and everything, but I think there are some displays in here that go back a long time, like into the 80s or the 70s. I think this is one of those displays. I mean, Lordy, looking at the fashion here, how would you timestamp this?
1992.
1992.
Yeah.
Oh, okay. Yeah, you're probably right. Yeah. The high jeans like that and the denim shirts tucked in. There are still some paleontologists who definitely dress like this. That's why it's kind of difficult. I was looking at this mustache right here. It looks kind of 70s, but again, I don't know. Paleontologists, we're not the most fashion-forward individuals. So maybe this is a fairly new display. I don't know. Yeah. And over here, this guy. This is a little bit more like I dress in the field. Yeah. Got a nice sauropod hind limb right there. Very cool. It's like probably a Patasaurus. But yeah. Pretty cool. Again, I looked at all of this stuff earlier, during the previous broadcast, so I don't feel like I need to really dally here.
How have the technologies changed?
Oh, let's see.
Glass method.
Oh, the read method, yeah. That's a great question. For the most part, I know I've said this before, but try and find an interesting way to say it again. For the most part, the way that we dig up dinosaurs has not really changed much since the Wild West days, since like the time shortly after the Civil War. That's when a lot of these techniques were first pioneered, and we're still using a lot of the same techniques today. So doing stuff like making these plaster jackets in order to help preserve and protect the fossils on their way back to the laboratory. A lot of the tools that we use are still the same. And I can show you some of them over here. You know, things like, masonry chisels and rock hammers, dental picks. A lot of this stuff hasn't really changed all that much. I mean, most of our work in the field is still done by hand. There's really the major changes are in things like connectivity. Like sometimes we can get internet connectivity in the field if we're really lucky. We might have walkie-talkies, like weather radios and stuff like that. We've got internal combustion engines, so like we can drive a truck out to our field site rather than riding a horse or walking sometimes. And if you're really lucky and you're on a crew that has a sizable budget and you're working in a really remote area, you might even have a helicopter that could help you move fossils like from the quarry into the back of a truck or something like that so you can take it back to the museum. But for the most part, the way that we dig up dinosaurs hasn't really changed all that much in the past 150 years. I mean, we're still out in the sun all day, digging through the ground and with little hand tools. Sometimes we'll have a jackhammer or something, but really, there's not much that you can improve, Things like, I get questions a lot about like ground penetrating radar or like using drones to find fossils or something. None of that stuff works. I mean, so much of it is still really, really analog, like you need trained eyes on the ground. Trained eyes and hands and knees on the ground. It's pretty low-tech stuff. That's why fieldwork can be kind of difficult. And it isn't for everybody. I mean, Hoping next year I can show you what it's like to actually dig up dinosaurs in the field, but we'll see. We might have some technological limitations and some connectivity limitations. Lordy, what do you say we move on into the next hall here? Yeah, into the dinosaur halls. It's supposed to be like a field camp in here. Actual, like, hard walls. Pretty neat. My favorite planet right there. Alright. Pretty neat. Oh, that's cool. Just getting us in the right frame of mind as we're traveling back in time here. From the Big Bang to creation of stars, and the death of stars, the creation of heavier elements, the formation of our solar system, organic material, eventually being able to reproduce itself, enzymes, and life. And here we are, in the Precambrian. Again, looking at that big chart earlier, you saw how lengthy the Precambrian is compared to all these other time periods. And we really don't have very much Precambrian stuff in here because the fossils in the Precambrian, they tend to be rare. It's tough to find rocks that are that old that still preserve the fossils. The rocks are unmetamorphosed. It doesn't happen very often. So we have very scant few Precambrian fossils, despite how long that span of Earth history is. But yeah, these are some things from like the Ediacaran fauna. We talked about this a little bit last time, so we'll continue on. Do you remember what these are called, Lourdee? We saw these at Museum of the Rockies too.
Stromatolites.
Stromatolites. Yeah. Did you remember? Did you read
No,
the
I
sign?
totally read the sign.
Fair enough. Yeah. Stromatolites, everybody's favorite
remember them,
living
though.
rocks.
I remember them.
Yeah, photosynthetic colonial bacteria that form these really cool mounds. And you can still see them in Australia today. Yeah. There we are. And have I lost our connection here? Hang on, I did here for chat. Maybe we moved to a different router or something? But,
I'm still on chat.
yeah, I just have to reconnect my phone. This is network as is. There we go.
So cool, yeah. Oh!
Okay, I think we're good. Anyway, yeah, Stromatolites. I love the erupting volcano in the background there. It's very cool. Yeah, what a peaceful time on Earth when these were... This is the most happening thing going on in terms of life. We're stromatolites.
Are stromatolites and coral examples of convergent evolution?
Yes, I guess, because they're not related to corals. They're bacteria. So yeah, in as much as they might be similar, that is convergence. But if you were to say that to like a coral researcher or a stromatolite researcher, I don't think they'd be super happy. Because they're like, no, they're completely different from each other. But to you or me, I mean, people who don't study these things, it might look fairly similar to a coral, but they are very, very different. Corals are actually animals. And corals have like a mobile stage early on in their life that that stromatolites did not. Let's disconnect from that, and I will connect to my own mobile Wi-Fi, and hopefully that'll work. There we go. I can read chat too. Disconnected. Connected. Okay. It's Urcus. I will put them in the fungus category. Well, these are not fungi. They're cyanobacteria. They are photosynthetic, like almost like blue-green algae, to use kind of an outdated term. Yeah. Stromatolites. Along a Precambrian coastline 2 billion years ago. It's a lot of zeros. 2 billion. We'll go over here. Everybody's favorite Cambrian ecosystem. We've moved up from the Precambrian into the Cambrian period. This is what Utah would have looked like about 500 million years ago.
Did you say that stromatolites are still alive, or the remains only still in Australia?
Yeah, we still have living stromatolites in Australia. The thing is, with stromatolites like that, I'll go back over to the stromatolites while we're talking about it. Stromatolites like this, they're kind of defenseless. Corals will have stinging cells. They'll have like different creatures that live symbiotically with them to protect them. These are just on their own. And if you have like a bunch of snails going through, they could just wreak havoc on some stromatolites. So stromatolites today are really only alive in areas where predators and grazers and stuff can't get to them. So like Shark's Bay in Australia is this hyper-saline environment. There's tons and tons and tons of salt to the point where things like snails can't survive there. But stromatolites can. It's kind of a safe haven for them. So stromatolites are still around today. And yeah, they're just kind of rare because lots of other things have evolved to eat them. They kind of evolved before anything could graze on them. So yeah, moving on into the Cambrian period, about 500 million years ago. These animals that you see here are all based on, they're mostly based on the Burgess Shale fauna from British Columbia. Big predators like Anomalocaris. These are all probably about double life size right now, we're seeing here. This is a lovely painting. You see it's canvas there. This is gorgeous. I like this a lot. All along here. And then we've got actual fossils from the Cambrian of Utah. Millard County, all these beautiful trilobites through here. Really cool. Just gorgeous. Look at those. Look at that. Absolutely beautiful. Now, when we interviewed Rebecca Hunt Foster, her husband, John Foster, he sometimes works on dinosaurs, but he also works on Cambrian trilobites, which is cool. It's a pretty eclectic group of research interests. Other various creatures from the Cambrian. Anomalocaris. This is this big predatory thing. That is like the tip of one of its grabber arms right there. And that little block. You see it? Pretty neat. Yeah. Anyway, lots more trilobites. Got some crinoid type things. I'm not even sure what these are. Eocrinoids. Very cool. It's like a crinoid ancestor. Other weird animals.
32 feet long and 14 feet high.
Pretty cool.
1,500 feet.
Anyway, speaking of trilobites, as we were a minute ago, we've got a giant trilobite right there. That's probably like a Permian trilobite. I think that's when they get at their biggest. That's like life size right there. Wow. Yeah. Pretty cool. It's not often you see a trilobite from underneath, so that's a cool display. I like that. And then this is very similar to that Museum of the Rockies display that we saw. This might even have some of the same models in it. We've got all kinds of swimmy, squiddy guys, nautiloids and orthocones. Cool stuff. And some early fishes. It's like very similar to one of our ancestors right there. An early fish. Kind of reminds me of like Haikuichthyes or something like that. But this would be more derived than Haikuichthyes. Pretty neat. And then I want to pay special attention to everything overhead right now. We've got some big old Eurypterid. These things are giant arthropods that lived in the seas. These might be the largest arthropods that ever lived, actually. Eurypterids like this. Also known as sea scorpions. That's life size right there. Pretty cool. There's an early shark ancestor. That might be like, I forget how to say it. I've never heard it pronounced. Cladocoelage? Cladocoelachy, something. Pretty neat. And look at all of these trilobites. Just a myriad of different sizes and shapes. Just wonderful. Yeah. Really cool. This is a model. This is not a real trilobite fossil. But some of these certainly are real. Which is really cool. Really neat.
Was Cambrian life only in the seas or some ventured on land?
That's a great question, yeah. Most Cambrian life is definitely in the seas, yeah. That's what we have record of. I think it's not until like the Silurian that things start to come onto land, and the first animals to come onto land, as far as we know, are things like Eurypterids, arthropods. Kind of like this guy right here. Some of these may have been like amphibious, may have come up onto land, but they're pretty well adapted to life in the water. Yeah. Beautiful. Some crinoids, got some trilobites, some really cool cephalopods. Oh, and right down there, you've heard me talk about Petoskey stones before. Is anybody here from Michigan or spent any time in Michigan? Along the west coast of Michigan, there are these really cool stones that you can find. There's one right down there in the corner. It's called a Petoskey stone, and it's named after Petoskey, which is a town on the coast of Michigan. Up in like the Midwest United States, up near Canada almost. And that is actually hexagonal coral. What you're seeing right there, it's almost like you took a beehive and like sliced it, and you can see all the little chambers in there. Those are coral polyps. They would form this big colony, and you can, where it's really shiny and smooth at the top, that's where it's been polished. Really beautiful in cross-section. It's called hexagonaria because they're hexagonal in shape.
What was the first life to come onto land?
It was, I think, insects or some other kind of arthropod. I don't know if we know for a fact whether Eurypterids could actually come up onto land. Like this guy, or like this guy up here. See this above me right now? That's another Eurypterid. Maybe these guys were amphibious? I don't know. I don't know enough about this kind of thing to know what the latest consensus is. But the earliest animals to come up onto land would have been invertebrates like that. Big arthropods like that. And check that out. That's the same Dunkleosteus model that I think they had at MOR. And here's some of our ancestors, the first like land-living vertebrate animals with the backbones to come up onto land, were descendants of these guys. These are lobe-finned fishes, kind of like coelacanths. So this is along our line. Like this is on our family tree, if you go back far enough. One of our ancestors. Pretty cool. Check out these fishes. Really neat. Yeah, see how it says Bear Gulch, Montana? Mm-hmm. We saw these at Museum of the Rockies, too.
Oh, yeah.
Yeah. Pretty neat. Like weird holostean fish. Chimeras and kinds of weird shark relatives and things. Oh, there we go, yeah. Cladosilach. Cladosilaki. I don't know how to pronounce it. I've never heard it said. Only read it in books, but yeah. This weirdo sharky guy. This looks like... Tell me if you agree. It looks like if the creators of Bob's Burgers designed a shark.
Yeah.
You think so?
Yeah.
I think so too. How are you doing?
Good.
Cool. Really cool fishes. We're just going to cruise through here. Some of our ancestors here, the lobe-finned fishes. And then this talks about coal and its formation. We talked about this a little bit last time. I think this is maybe where I lost signal last time, so we'll cruise through here. Into the Carboniferous period. The Coal Age, as it's sometimes called. A lot of the coal that we have, especially in places like Pennsylvania, comes from the Carboniferous period, when Earth was covered by these gigantic forests, all of these huge primitive trees. I've heard this described as a time when, like, when trees were kings and vegetation ran riot upon the Earth. And there wasn't really much, I don't think fungi had really evolved to the point where they could break a lot of this stuff down. And so the plants would just, when they would die, they'd just fall into the ground and basically compact in huge layers, which eventually became coal. Some Carboniferous plants right here. And some giant horsetails. A lot like, yeah, that looks very similar to today's modern equisetum. Modern horsetail plants. I hope Ios has remembered to water my horsetails.
I think she did.
Okay, good. Got these over here. We looked at these last time, too. Some ichthyosaurs, giant ammonites. Ichthyosaurs are not dinosaurs. I have one of these on my ukulele, a skeleton. And here's an ichthyosaur skeleton right here. Looks like maybe Ophthalmosaurus with those big old eyes. Yeah, very cool. This has got to be a cast right here. They wouldn't have given a genuine ichthyosaur to this museum, right?
So Claire's wondering if we won't be making coal now that the world is full of fungus.
Coal still does form, but not in the tremendous quantities that it did back then. Yeah. We've got coal from lots of different times. I've dug through coal layers to find dinosaurs before, which is way later than that Carboniferous stuff. But I don't think we'll ever have the amount of coal being produced in the ground now that we have, like, detritivores and fungi and stuff eating all that. Here, press this button right here, Lardy.
Whoa.
Isn't that cool?
That is really cool.
So that's an ammonite showing you all of the chambers inside. So as these animals would grow, they would move to a new chamber they'd kind of build a new one every year or a few months or something like that. I don't know the exact time frame, but yeah, they grow and expand as they age. It's ontogeny in a cephalopod. Super cool. Yeah. All right, moving into the Permian period. Actually, we looked at some Triassic stuff right there and some Jurassic stuff. Well, a few of these things are kind of out of order. We've got one of everybody's favorite non-dinosaurs, Dimetrodon. As I've said many, many times, this critter right here is more closely related to you and to me than it is to any dinosaur. This is basically like a proto-mammal, Dimetrodon. Very, very charismatic animal. You know, when you probably remember these from when you were a kid, everybody watching. You could get, like, at the dollar store, like a bag of, like, little dinosaur toys, just like assorted dinosaurs. They almost always have Dimetrodon as one of those. One of the non-dinosaurs that they would include as dinosaurs. So yeah, Dimetrodon, usually like woolly mammoth, some sort of pterosaur. These are things that a lot of people in the general public take to be dinosaurs, but they're not. Yeah.
What are clues that the spines on the Dimetrodon make a fin instead of a hump like the buffalo the other day?
That's a great question. I think it's because these neural spines are just a lot thinner. So like with the bison, or maybe with Spinosaurids or Acrocanthosaurus, those neural spines are a lot longer from front to back. Antero-posteriorly, lengthy. These are just really, really thin. And take a look.
There, that's the theory.
So, and they just have a lot less heft to them. They don't seem nearly as structural as the spines on, bison latifrons or on Uranosaurus or Spinosaurus or something like that.
After the meteor
Yeah.
crash, if you not 100
Yeah,
years,
pretty cool. Yeah, and we've got Ariops. These are these cool reptilomorphs. I don't know what they ate. Maybe they were generalists. Maybe they ate fishes and stuff. But they are a presumed prey of Dimetrodon. Pretty cool. Let's see. And exactly, Javasaurus. Yes. No muscle insertion points on the bones. Yeah, Boken. You're right. That's a good point. Yeah. You don't find muscle scars on those in the same places that you find them on neural spines and stuff too on other creatures like bison, like Spinosaurids, like Uranosaurus. This is cool. I don't know if I showed you guys this last time. Check out this beautiful crinoid forest here. Trilobites and cephalopods. This is from sometime before the Permian extinction, I think. Huh?
Why do most dinosaurs have 3 fingers?
That is an excellent question. I can answer it right over here, actually. Let's go over to the Dinosaur Origins display. So here we have Herrerasaurus and Eoraptor. You guys are familiar with Eoraptor from seeing it on my channel before. There's that skull. I've got some 3D prints of that skull. So dinosaurs, here's the thing. When it comes to number of fingers, usually that number can only really go down. It's really easy to lose fingers through evolution, if you don't need them. It's really difficult to evolve new ones. It's a lot more difficult to gain fingers than to lose them. Dinosaurs start off, we think, with probably 5. So with this Eoraptor right here, 1, 2, 3, 4. Interesting. We should probably have 5, I would imagine. But yeah, it's a primitive characteristic for dinosaurs to have more fingers, and they kind of lose them as they become more derived. As time goes on, as they evolve, as they become more specialized, like I said, it's easier to lose fingers than to gain new ones. And so, we've got super derived dinosaurs, tyrannosaurs. They have 2 fingers. Some Alverosaurus may have only had 1 finger. And but 3 is really the most common. Like, usually dinosaurs that have 4 fingers, the 4th one is just vestigial. You can kind of see that happening right here with Eoraptor already, where that little 4th finger there, it's just like a little splint, basically. I don't know if we actually have complete forelimbs of Eoraptor, so that one might be speculative right there. But, yeah. Anyway. Like I said, the earliest dinosaurs, like I've said before, I suppose, not in this broadcast, the earliest dinosaurs were bipedal. This is kind of the primitive state for dinosaurs. And later, especially in plant-eating dinosaurs, ones that need to have bigger guts for digesting plant matter, it makes sense for them to get bigger and heavier, and then to move from walking on 2 legs to walking on 4 legs to help support that weight. So like sauropods, ornithopods, ceratopsians, thyreophorans like ankylosaurs and stegosaurs, they all move to walking on 4 legs to help support that enlarged gut. And they don't need to chase after their food either in the same way that meat-eating dinosaurs do. So it makes sense for them to go on all 4s and become slower. Anyway, pretty neat. So the earliest dinosaurs here that we have so far. Eventually, somebody will find some earlier ones, and we'll fill in some of those gaps. But for right now, Eoraptor is like the earliest definitive dinosaur that we have. At least according to most people that you ask. Bipedal crocs. No, I don't think there are any bipedal true crocodilians, but we might have some Rawasuchians or what we used to call like Ornithosuchians. I don't know if any of them are on display though here. We saw some in some other museums earlier. Who was asking that? Spinobreaker. Yeah. We don't have any. I don't think there are any at this museum, but we'll see. Yeah. I know the museum in Rapid City that I visited had some Rawasuchians, some Postosuchus and stuff. But yeah, anyway, you ready to continue on into the Jurassic period, Laura? Here we are, moving up in time from the Triassic into the Jurassic. And we're just going straight into the late Jurassic, I guess, Morrison Formation. And this is such a cool hall. I think we'll start right here with Tenicolagreus. This is a meat-eating dinosaur. A pretty rare one. There are a number of models of it and skeletal casts in this hall, which is pretty neat. But yeah, this is probably the best known of the small theropod dinosaurs of the Morrison Formation. It's like a small, fast-running, almost like a dromaeosaur before there were dromaeosaurs. And these look like the actual fossils there. I don't see any specimen numbers, but these could be casts, but they look pretty genuine. Pretty neat. There's the skull over there. We've got just a few bones there. But I like the way that this is all arranged. This is nice. Pretty cool. So this must be the specimen that these skeletal casts up there are based on. So we'll go take a look at that. Of how the fossils are found? This? No, certainly not. Here, we'll go back and look for a second.
And was that the Morrison Formation?
Yeah, this is from the Morrison. This might be from Bone Cabin Quarry again. Yeah, Bone Cabin Quarry West, back in '95. When dinosaurs are found in the ground, they are not found like this, typically. Usually much more chunked up. It's not, this is all beautifully arranged right here to kind of give you a sense of where all the different parts fit. We do not find them in the field like this. In fact, when they're found in the field, you should look at that photo right there. Each bone has to be individually removed from the ground, usually, if it's a disarticulated specimen. It's not nearly this pretty. It really requires kind of an expert eye to be able to see everything and then be able to get it out of the ground in a way that doesn't harm it.
Extra stuff for the guts.
Who did?
Webmeister.
Webmeister, thank you so much. Really appreciate that. Yeah.
Dino Mama asks, their daughter asks if there's a baryonyx there.
There is not quite baryonyx, but if you like Suchomimus, then you're in for a treat. I seem to recall there's a Suchomimus skull over in the Cretaceous Hall, which I didn't even get to last time. So yeah, that might be the dinosaur I'm most excited for too. So Suchomimus is a very close relative of baryonyx, so I'm excited to show you.
Awesome.
But that'll be in a little while. We're still in the Jurassic right now.
She said,
Oh yeah, Suchomimus, absolutely. One of the dinosaurs I work on. I've got a paper coming out, hopefully pretty soon, about the feeding ecology of spinosaurids, including Suchomimus. Suchomimus played a really important part in that research. All these little beaky plant-eating dinosaurs here. Ophnelia or Ophnelosaurus or Nanosaurus, or the taxonomy of these guys is kind of a mess. They're really cool. Yeah. Pretty neat. I wonder how much of this is based on real fossil material. You can see how the tibia and fibula and the femur have a lot of texture right there. Those look like real elements. Maybe not the femur. A lot of these look like they're sculpted. They're just too perfect. And I wonder how much of that skull is sculpted. The skull looks a little too perfect too. But it's cool to have so many of these all in one spot. It's like a little nest. Pretty neat. Pretty neat. And I like how there's an area for kids. A little tunnel for them to run through in there.
That's really cute.
There might even be some more of them in there. I'm not sure. I'm not going to go running through there myself.
Java says their metatarsal are not fused yet.
Yeah, that's right. Yeah. And these guys still have... It's interesting. Some of these ornithopod dinosaurs have like derived characteristics, like they'll lose the hallux. Like if we see a Dryosaurus, you won't see that digit 1 right there. Yeah. But these guys still have unfused metatarsals, you're right. Kind of a primitive characteristic. Anyway, I was talking about the tunnels for kids to run through. I wonder if this is an allusion to the idea that these dinosaurs may have actually raised their young in burrows, like Eryctodromius from Idaho, from the Cretaceous. I think these displays are probably produced before we knew about Eryctodromius, but yeah, anyway. These guys may well have raised their young in burrows. We've got a Tinnicalagrius, that meat-eating dinosaur, pouncing upon a hapless Ophnelia right there.
How often do you think multiple species that happen to be in an excavation area get placed together to make a proposed dinosaur specimen?
That's happened a few times. We call that a chimera, or a chimeric specimen, where you've got the remains of multiple different animals kind of squished together. Spinosaurus is probably like that. So like the new Spinosaurus that everybody's all excited about seems to probably be a chimera. There's probably multiple different kinds of Spinosaur making that up. Yeah, it happens. It happens sometimes. And even in some like major museums, there have been dinosaurs on display that have had bits and pieces from completely different animals. Like for decades and decades, the Smithsonian Institution in Washington, D.C. In the Museum of Natural History there, they had a Triceratops whose back legs were not Triceratops back legs. They were hadrosaur back legs from a duck-billed dinosaur. And this is just like a grievous error that they had for years and years and years. Yeah, and like very few people noticed. It's since been corrected.
We just got 5 gift subs from Dork Apocalypse.
Apocalypse, thank you so much. Holy cow.
Thank
really
you so
appreciate
much
that support.
for that support. We
Wonderful.
really appreciate it.
Yeah.
You guys are helping make this whole road trip happen so that
That's
we
awesome.
can stream live to you guys. So
Thank you for your support. Wouldn't be able to do this without you, so thank you. So we are now at 5?
At 5 what?
5 gift subs?
Yes. It says 5, but I think we've had 7.
Oh, okay.
7 subs. I'm not sure why it's not updating properly, everybody.
Yeah, that might be a little late there. But yeah. Anyway, really cool Tinnicalagrius. I've not really seen this at many other museums, so this is cool. It looks like they used some dromaeosaur bits to kind of fill in some gaps there. But pretty neat. And then here is a fleshed out reconstruction of a Tinnicalagrius chasing a Othnielia, I guess. Both very scaly, very dramatic. Really waggly tail there. Most dinosaurs, their tails were not that flexible. They're used for balance and for muscle attachment. They're not like a lizard's tail or something, really. Yeah. Continue on through here. Here we'll check out the Stegosaurus down here. So, this particular cast, this has been, if I remember correctly, I think it's this specimen, has been nicknamed the Roadkill. Yeah, because it's just very flat, very intact. You see this in a lot of different museums. And here, we've got some Goniopholis, these late Jurassic crocodilians. Looks like eating this dead stegosaur. So I've said before, oh, and there's a baby stegosaurus over there who seems not too happy about this situation.
Yeah, great.
Yeah. Anyway, I've said before how mounting a dinosaur skeleton is really time-consuming and expensive and takes a lot of expertise. So sometimes you just put your dinosaur skeletons on the ground and you find creative ways to turn that into a compelling display, like they've done here. Pretty cool. Pretty cool. I know this was a highlight of the stream last time, but check this out. Supersaurus up here. Enormous.
I'm like 8 feet tall.
Yeah, Laurdee is, what, 8'11"?
8'11".
Yeah,
8'10".
8'10"? Okay.
Yeah.
So look how tall that dinosaur is by comparison. Yeah, Supersaurus. We will actually see real elements from this dinosaur over in the display right there.
Have you been part of assembling a dino skeleton before?
I suppose I have been, yeah. Like putting a new head on a dinosaur skeleton. I've helped repair skeleton mounts and that kind of thing, but I've never like put one up from the ground up, like from scratch. That's something I would love to do in the future. But yeah, I've never done one from the beginning, you know? Yeah. I know a thing or two about it, but don't have a lot of experience with that. Here's the skull of Diplodocus right here. And, lovely cast. Look at those very, very narrow teeth. Diplodocus teeth have been described as kind of pencil-like, but really they're even thinner than that. These are not for chewing. These are just for kind of nipping plant material. In fact, look at how much space there is between the teeth right there. I remember talking with Kerry Woodruff about this once, who's a sauropod researcher. He works on Pachycephalosaurs now, but he really started off on sauropods, and that might be his true love, sauropods. It's long-necked plant-eating dinosaurs. He was looking at these teeth, and he's like, it would make a lot of sense if these guys mostly ate plants at ground level. Maybe they specialized in eating ferns. There were a lot of ferns during the Jurassic at this time. And those teeth may have just been used for kind of like stripping the little leaves off of these fern fronds. So basically, like, picture sticking a fern frond in there, and then closing the mouth, and then just kind of pulling it out between the teeth, so that all of the little leaves end up in the mouth, and then it's basically just like the stem on the frond is left bare afterward. So you're getting all the nutritious parts without having to deal with the stem. Maybe that's what these guys were doing. And given that they only have teeth in the front of their mouths, they're that widely spaced and everything, maybe that's perfect for that. I don't know. It'd be cool to do some actual tests, maybe isotopically, or even just like micro-wear tests to figure out how these teeth seem to have been worn over time, you know? Yeah. Large floss budget. There you go, David Accounting, yeah. Well, basically, it's like flossing your teeth with ferns and, eating the stuff that gets left in there. Yeah. I have a cast of this at home. This is so cool. This is Camptosaurus. There were some more Camptosaurus elements in there that I didn't point out. This is one of these unheralded ornithopod dinosaurs. They really don't get enough attention. Remember yesterday, Lordy, we were looking at the display with all of the different skulls from the Cleveland Lloyd Quarry? And I'm like, pick your favorite.
Yeah.
I picked Camptosaurus because Camptosaurus needs some love. This is the hand of Camptosaurus. So, it's smaller than my hand, yeah. This would be a big animal, like the size of a cow. It's not a big dinosaur by Morrison standards, certainly not. But we'll look at its hind limbs over here.
Okay.
And I'll show you how much more robust those are. There we go. So that's a Camptosaurus foot right there. This is what Camptosaurus would look like. Fairly nondescript ornithopod dinosaur. No big horns or frills or spikes or teeth or anything like that. But you know what? It's an important animal. Look at the size of the foot compared to the hand. Look at how much more robust that is. Yeah. So these guys may have been mostly bipedal. Maybe they walked on all fours. Sometimes, I don't know. Earlier ornithopods are mostly bipedal. They kind of switched to quadrupedality afterward. Here we have a beautiful Ceratosaurus. Take a look at that. Oh my goodness. So as you can see, there are some sculpted bones in here. These are the ones that are just this matte black. And then the rest of these are the actual fossil bones. This is gorgeous. Just absolutely beautiful. You know, I wonder.
I love that they put they filled in the blanks.
Yeah. Makes it a lot easier to know what you're looking
Understand
at, right?
what I'm looking at.
Yeah. And I like how this is in two separate display cases. There's one here, and then Lordy's standing in front of the juncture between the two right here. And another display case. It's a good thing they put these in the correct order. This looks very similar to the one, I'm looking at the nose horn there. We were looking at the right side of a Ceratosaurus skull when we walked in earlier. You remember that? Mm-hmm. Or excuse me, we were looking at the left side. This looks like this is the right side right here. I wonder if this is the same skull.
Yeah.
If they've just split it up into two different displays.
Yeah.
Really kind of getting their money's worth. Yeah. Pretty cool. What a neat animal. It's got these big teeth. Ceratosaurus is kind of well known for having pretty large teeth, for its body size, especially compared to other Morrison theropods. So yeah. Pretty nifty.
This is a little interesting.
Yeah?
Moosey Fate says, when I mention birds as a type of dino, people seem to think dinos aren't a type of animal, but rather that it's about when the animal was alive.
Oh, yeah. I mean, that
These
is
animals, even though they are...
Well, no, I think the idea is that rather than a dinosaur like being a group of animals, that it's just like dinosaurs a descriptive term for prehistoric creatures in general or something. Which is not. Dinosaurs are a very specific group of animals. So dinosaurs were not. It's not as though like everything alive during the Mesozoic was a dinosaur. Certainly not. They are, like I said, a very specific group of animals. So, like, you can pinpoint them on the tree of life, and it's like everything from this branch on is a dinosaur. But no other creatures are dinosaurs. And there were a lot of other creatures that shared the world with dinosaurs during the Mesozoic. You had things like pterosaurs, like those flying reptiles up there. You had the, crocodiles, like the ones that we saw eating that Stegosaurus. There were mammals. There were insects, there were fishes, there were, lizards and snakes and frogs and all kinds of other creatures. Countless types of different invertebrates. It is certainly not the case that every animal that lived at this time was a dinosaur. Absolutely not. Couldn't be further from the truth. That being said, dinosaurs were
on the contrary, we
pretty dominant on land.
In the universe.
Almost every animal bigger than like a Cocker Spaniel during the age of dinosaurs on land was a dinosaur. Some crocodilians definitely got bigger than that. And some champsosaurs did too, but that's mostly every big animal was a dinosaur back then. Oh, and pterosaurs too. Yeah. But yeah. Anyway, down in this display, we've got some juvenile Ceratosaurus. These are probably casts, the one that we just saw right there, which is really neat. And they are feeding on this dead Camarasaurus. Check out that Camarasaurus skull. Just like the one I have in my office, but mine's about half the size of that. Pretty neat. Juvenile Ceratosaurus. Oh, and Paramedics Underground wants to know, saber-toothed cats sometimes break those big teeth during predatory activities. Do paleontologists find broken teeth in large carnivorous dinosaurs? Yes, absolutely yes. Far more common than you find in Smilodon or other saber-toothed cats. The cool thing about dinosaurs is that they've got an endless supply of teeth during their lifetime. As long as they're alive, they are growing new teeth all the time. And if those teeth get broken or worn out, a new tooth is already on its way to push it out. Even if they didn't wear down their teeth, a new tooth would still be on its way to push it out. It's like a constant conveyor belt of new teeth. Mammals like us, or like saber-toothed cats, are not like that. If you break your adult teeth, you're SOL there. Dinosaurs didn't have that problem. So say you're a young Ceratosaurus chowing down on a Camarasaurus here, and you're biting through the rib cage and you happen to break some of your teeth, no worries. In fact, we often find in dinosaur skeletons, if you're careful, if you do your work properly, and if you get every last little bit of information out, you will usually find shed teeth from carnivorous dinosaurs. And sometimes you'll even find like bite marks and stuff. Sometimes you'll even find shed teeth that are like embedded in other bones. So like tooth broke off because it got stuck in a bone and it's just there. So pretty cool indeed. This is another one of those cases where you've got a dinosaur skeleton on the ground because it's cheaper and easier than mounting it. And down there we've got a Jurassic ankylosaur. Man, I remember when I was a little kid, we didn't yet know about any ankylosaurs from the Jurassic. But now we've got Gargoyleosaurus. I think Mimurapelta might also be from the Jurassic, if I remember correctly. It used to be the case that stegosaurs were the only armored dinosaurs during the Jurassic period. And then when ankylosaurs show up, stegosaurs go extinct because they got outcompeted or whatever. Nowadays we know that they, shared environments for a long time. So we've got really cool ankylosaurs like Gargoyleosaurus right here from the Jurassic period. Pretty cool. Oh, dude, what kind of tree is this right here? Do you know? Ginkgo. It is a ginkgo, yeah. Beautiful ginkgo tree right here. These, of course, existed during the time of the dinosaurs, and they are still around today. There's one species left, Ginkgo biloba. It's become a really, really popular tree in cultivation. You see it in a lot of urban forestry. This is cool. Real versus cast. There are three main reasons why paleontologists make cast of bones. Yeah. Durability. So the real fossils are very fragile and heavy. Original bones need to be studied, so often they're kept in the collections. It can be really difficult to study something and take precise measurements if it's, 40 feet in the air. So yeah. And several identical casts of dinosaur skeletons can be made from an original, allowing many museums to show rare and unique dinosaurs that would otherwise not be available for people to see. Yeah. If you've ever been to a museum and seen a Carnotaurus skeleton, you should thank your lucky stars that we make so many casts, because there's only one specimen of that animal that's ever been dug up or described to my knowledge. Carnotaurus. So yeah, every one that you see in a museum is going to be a cast. I think the original is probably safely tucked away in some museum drawers. Yeah.
We just got 5 gift subs from Pontius Pirate.
Pontius Pirate, holy cow, thank you for the 5 gift subs. Really appreciate that. That means a lot. You're the reason why we're here, man. Thank you so much. Awesome. Here, we will walk along this way. Is this Gastonia up here? Looks like it might be Gastonia. And we'll check out this Brachiosaurus, and then we'll go down and through there. There we go. Yeah, Gastonia. No one eats ferns like Gastonia. No one's got spikes like Gastonia. This is a dinosaur from the early Cretaceous, so we're jumping forward in time a little bit before we jump backward again. But this is an ankylosaur that shared its environment with Utahraptor. So during the 90s, you may have seen like dinosaur documentaries, especially with Jim Kirkland talking about like Gastonia and Utahraptor like facing off. That's something that would have happened in real life, presumably. These are from the Cedar Mountain Formation of Utah, if I remember correctly. Yeah, and we have juvenile and adult right here. I think we actually have both of these represented from real fossils. Pretty cool. Look at those spikes. Just really awesome. And that giant, like, shield over the hips. This must have been like a particularly vulnerable spot. I wonder how much of this is sculpted and how much of this is actually based on the real fossil material. Whether it really was that tightly woven like that. But, yeah. The armor plating on these dinosaurs can be really, really difficult to, like, to reconstruct properly. Because all this stuff would disassemble after death. And so, you know, you'll see many, many different kinds of reconstructions of ankylosaurs with spikes here and knobs there and osteoderms just kind of all over the place. It's difficult to, like, really get that right when all this stuff just falls apart after death.
Were the spikes made of bone?
They were, yeah. So the word osteoderm, that's these, the spikes, means bone in the skin. That's exactly what it is. So these, I guess you could say they are part of the skeleton. I think they're made of the same stuff as bone. So, yeah, but they would have been covered by keratin, made even sharper or more resilient in life. Keratin is the material like in your fingernails. So, yeah. I really like this display. It's cool to see. There are a lot of, I don't know, I feel like there's a bias toward meat-eating dinosaurs, you know, chowing down on their food in museum displays. It's cool to see plant-eating dinosaurs eating their food as well. Pretty neat. And I like the cycad over here, too. I don't think this is based on a modern cycad. I think this is like, yeah. Most cycad reconstructions that you see are just based on the Sago cycad, Cycas revoluta. This is something different, and I'm here for it. I like it a lot. I wish I could get a real cycad like this, but I think, yeah.
What do the hips look like under that big butt plate?
That's a great question. Well, let's see if I can show you. It's a little bit dark under there, but these guys tend to have like really, really wide ilia. So like their ilium bones are really, really big and like shield-like. Oh, thank you, laurdee. Giving us some light there. So those like plates are kind of covering the ilia, and then you've got the pubis and the ischium are both kind of pointing backwards like that, because these are ornithischian dinosaurs. We might be able to see better on the subadult or juvenile over here. Yeah, there we go. So those are the ilia pointing backwards like that. Basically just, everything is kind of shunted to the back to make more space for that enormous stomach and those huge intestines that would digest all of this plant material. Really neat. I like that a lot. I also like the dried ferns there on the ground.
Yeah, it's a good touch.
It is a nice touch, yeah. You don't see enough of that in museum displays. And I like how there's even some, like, you know, brown, kind of like dried, I guess these are giant tree ferns. Very cool.
Does ilia reflect hip mobility for speed at all?
No. In dinosaurs, the hips are like, they're locked in place. They don't move around. I can show you when we get to those sauropods over there. Yeah. No, I think ours are also stationary, I think. There might be a little bit of flexion there or something.
Just for comparison.
Yeah, yeah. Because your femurs, you know, your femur heads move, they're in your acetabula, your like hip sockets. I don't think your hips really move a lot. Like they're not kinetic. It's basically they're like the center of gravity and everything else kind of moves around them. Check out this.
This is a really fun display.
You like this?
Yeah.
Yeah. We've got Ankylosaurus right there.
Who is it now?
Some kind of theropod in the middle. Oh, and Spinosaurus right there, presumably. You got a stegosaur tail. Cool.
That's fun.
Very cool.
That's fun for the kiddos.
Yeah, I like that a lot. I brought you over here so you could see this. Brachiosaurus. Just nuts. I was thinking for a while, like, why don't I print a brachiosaur skull? I'd forgotten just how big they are. I mean, look at that. It's like half my office right there.
Right.
That's nuts. Before we look at that, though, let's check out... They've made a lovely little display here with dinosaur models from Safari Limited.
Look how gory that is.
Yeah, yeah.
It's awesome.
You like that?
I'm going to take a picture.
This is a big departure from what we had for lunch. We were at a vegan restaurant for lunch. Yeah, look over here. Allosaurus eating what looks like a poor iguanodon. Yeah. Cool stuff. These are all like, I had a lot of these toys when I was a kid. That Dilophosaurus, this iguanodon. It's cool to like see them in a museum display. Some of you in chat almost certainly had some of these toys. Maybe still do.
With the like bone pit in the back.
Oh, wow, yeah.
History, like what happened.
Oh, that's cool.
There, yeah.
Uh-huh. These are all different dinosaurs from different times, though. Or maybe it goes, I guess it does go from Triassic, Jurassic, Cretaceous.
Oh, that's cool.
Yeah. There's Tanystropheus down here. And, oh, there's a giant placoderm fish. That almost looks like it was sculpted. That doesn't look like it's commercially available. Yeah. This is like Triassic here, save for the giant placoderm. There's Ankylosaurus or Platyosaurus or somebody. What we used to call a prosauropod. The early Jurassic, you've got Dilophosaurus and then Stegosaurus there. And Iguanodon for some reason. Iguanodon's from the early Cretaceous. Apatosaurus, Diplodocus, I think. Allosaurus, Brachiosaurus. That's a wonderful spot for that Brachiosaurus to be. I had that same Brachiosaurus when I was a kid.
Yeah.
And you know what I used it for?
What?
At Christmas time, that was my like stocking hanger. As I'd put the stocking around its neck, and it was big and heavy enough that it would hold it there. Yeah, and there's a Baryonyx back there, Saltosaurus, Pachycephalosaurus, a very antiquated Spinosaurus right there. Holy moly. It's basically just like, I don't know, a Megalosaurus with a sail on his back. Something like that. But this is cool. I like this. The emphasis here is really on the landscape and the geological forces and stuff. Yeah. Pretty cool. I wonder how long this display has been around. But we're going to go down this way, Lordy. Big old Brachiosaurus. This is amazing. Again, just to give you a sense of scale here, can I have you stand up against here, Lordy?
Yeah.
So, again, Lordy is, what are you, 9'5"?
About.
Yeah, yeah. And big this animal is by comparison. Really, really big. Yeah, yeah. All right. Let's walk down here. We'll have some pterosaurs overhead. All kinds of different pterosaurs. rhamphorhynchids and pterodactyloids. Pretty cool. Pretty cool. I wonder if those are still the two main like subgroups of pterosauria. Is it still rhamphorhynchids and pterodactyloids, or has it become more complicated than that since I was a kid? It probably has been. I would hope it would have been. I don't know. But there is Supersaurus right there. Just astonishing.
Oh, this is the Supersaurus.
Yeah. This is Supersaurus. Check that out. Look at the size of that rib cage. That's bigger than my office right there.
It is.
This dinosaur is like 5 times bigger than my apartment.
Yeah. For $900 a month rent in the Bay Area for that rib cage.
Easily, yeah, double that, $1,800 a month to live in a Supersaurus. Just look at that, just huge, huge, huge. And there's those hips up there, like we were talking about. You've got the pubis hanging down in the front. You've got the ischia in the back and the ilia on top. So pubis, ischium, ilium. And when we're talking about multiple, you pluralize that. But these are the actual hips right here. Or the ilia and the sacrum, I guess. This is real.
Whoa.
Yeah, check this out.
Enormous.
Huge, right?
Enormous.
Yeah. So, again, this is the ilium right there. See that kind of rounded, almost like bowl shape in there? That is the acetabulum. So that is where the femur fits in. And so this is all basically like one solid block of bone when the animal's alive. And this is the center of gravity for this animal. So the femur would be in there, swinging back and forth. And then here are the neural spines on the sacral vertebrae. So the backbone runs all the way from the back of the animal's skull to the end of its tail. But right there in the middle are the hips. And so you've got the sacral vertebrae up there. Look at how most of this animal is most of the bones are really smooth in this big reconstruction. But look at how scrungy they are right there above the hips. You know why that is? It's because that's based on real material. It's based on this right here. So this, I believe, is on loan from BYU Young University. Maybe they just didn't have the space for it. But it is enormous. Here's a cross-section of the vertebra right there. There's the centrum of one of the sacral verts, that big neural spine. This is so big that it was probably semi-crushed by its own weight back when the animal was decomposing before it was fossilized. And then I'm sure the weight of the overlying rock would have compressed it even further and deformed it even more. But really, really cool. And check this out. I know we talked about this the last time I streamed from here too. Look at this custom-built metal frame. We've got some steel I-beams in there, and all of this really intricate, precise, really cool welding going on. Again, if you're interested in welding, that could be your ticket to working on dinosaurs potentially. We are always in need of good metal workers to help put up skeletal mounts like this and display things like this. So, really good. Very, very cool. So this, of course, again, real fossil right here. You can see the specimen number right there. BYU 725 must be the locality. And specimen number 13018. Wonder how much this thing weighs. This has got to be, what, 2,000-3,000 pounds? Maybe more?
So, are fossils heavier than the bone would have been in life?
Yes, much heavier.
Okay.
Yeah, because they're basically
Rocks.
Yeah, they're turned to stone, kind of.
Yeah.
They're permineralized.
Okay.
Yeah. Yeah, yeah. Pretty neat. And then something like this, it's not just, if it were just turned to stone, permineralized, it would be heavy enough, but it's still got tons of rock in there too. Yeah. Yeah. And look at the shoulder blade right here. Scapcoracoid. This is real too. Yeah. So that is that bone up there. Yeah. And there we go. I mean, enormous. Okay, let's get you in front of that, laurdee, just for a sense of scale. Again, get your arms out. This is like 11 feet from here to here, right?
Yeah. I don't know, like 10 foot 10.
Oh, okay, yeah. Look how big that is. You just keep growing. Yeah. And here, let me. Dank chat is being. It's doubling up all my messages again, so let me start it over.
How did the different hips between
Ornithischians
ornithischians and saurischians evolve? I know one points back and one points forward. Do they function differently physiologically?
I mean, they're still just hips, The thing is, here's a good example over here, actually. We'll take a look at this Allosaurus skeleton. This is a saurischian dinosaur, so a lizard-hipped dinosaur. There's lizard-hipped, saurischian, and bird-hipped ornithischian.
A versatile sort of chap.
It's confusing because the bird-hipped dinosaurs are not the ones that birds evolved from. Birds evolved from lizard-hipped dinosaurs.
Less than 3.
Theropods. Anyway, the pubic bone, the pubis right there, points forward in saurischian dinosaurs. And then the ischium points backwards. Ilium is on top. But if you look at ornithischian dinosaurs, like this Stegosaurus over here, they're calling it Hesperosaurus. Fair enough. Stegosaurs are kind of a mess taxonomically. You've got the pubis points backwards along with the ischium. And then there's also there's a process on the pubis that also points forward too. But ornithischian dinosaurs are all plant eaters. All of them, all of these guys, the bird-hipped dinosaurs, are plant eaters. And so not having the pubis point forward gives them more room in their gut area for digesting plant material. With these guys, they don't need to have nearly as big a gut. So all of their intestines are probably forward of the pubis, I would imagine. They just don't need as much space there. Yeah. Yeah, does that make sense?
The moon's up for 6 months.
The moon, thank you very much. That's half a year right there. I appreciate your support. Thank you for that. I am grateful. Yeah. These look like the same juvenile Allosaurus we saw yesterday at the Utah Museum of Natural History in Salt Lake. Very cool. And it's even got has it got the furcula in the front? Let me see. It does. It's got that little wishbone right in the front. Between the coracoids. Very cool. Very cool.
Just FYI, sometimes when you point upwards, it's out of frame. You point the camera when you point up.
Okay, yeah. I'll try and do that.
Yeah.
This is a stegosaur. This one, the sign is calling it Hesperosaurus. Isn't it Hesperosaurus? I could be wrong about that. Yeah. So they're claiming this is a different genus from good old-fashioned Stegosaurus. I don't know enough about Stegosaurus to be able to really comment on that. I do know that Stegosaurs are surprisingly understudied. So yeah. I wonder what Susie Maidmont would have to say about this. Stegosaur specialist. Yeah. Look at those plates. This is just like a single row of big dorsal plates. Very interesting. Again, I would wonder, is this a chronomorph of Stegosaurus? Is it the same lineage, just, a million years more recent or a million years further back in time? I don't know if we've got good stratigraphic constraints on these animals. I don't know. The skull certainly looks different from Stegosaurus that I've seen before, but I think Stegosaurus skulls are also often like misportrayed in a lot of reconstructions. And there's that Thagomizer right there. That array of tail spikes. Very cool. And here's a really neat display. Check this out. This looks real right here. This looks like it could be a cast. Yeah. No, this looks real. It must be this is the part that was exposed, which is why it's so much lighter colored. And then the rest of it is not sun bleached. But check out that stegosaur spike. Just crazy. I wonder if this might have... It doesn't look like it has keratin preserved over it. And these spikes got enormous on some of these animals. Maybe this is a different species. Maybe this is just a fully mature animal. But check that out. That's nuts. Yeah. Very, very cool. Imagine... Or maybe don't. Imagine getting stuck with that. Ugh. Would not be a good day. That would not be a good day. Here's Torvosaurus right here. We saw the skull of this guy yesterday at the museum in Salt Lake. This is one of the rarer theropods in the Morrison Formation. Also one of the larger ones. So most of the big theropods in the Morrison turn out to be Allosaurus. This guy is something different. This is a megalosaur. Really weird. I mean, we don't have many megalosaurs from North America. I guess we don't have many megalosaurs from anywhere, really. They're not super common. But, yeah, check that out. This makes you wonder, like, what are these guys doing differently from Allosaurus and Ceratosaurus, that they can all coexist in the same environment? Yeah. Very cool. Very, very cool. And I wonder how much of this is actually based on real fossil material. Like, I know a lot of this stuff is really scrappy. It's funny, because we've got so many skeletons of Allosaurus, some of them reasonably complete. And Ceratosaurus, too. I feel like we've got some really good Ceratosaurus specimens. Torvosaurus, though, I think is known from fragments. I don't even know if we have a decent skull of Torvosaurus yet. That's all sculpted right there, you can see. Maybe the lacrimals are real. Maybe part of the maxilla, although that all looks sculpted. I don't know. I don't know my Morrison theropods that well. Yeah. And it's Urca. That would be really cool for them to have. They might even talk about it on the display. No, it doesn't talk about that there. No. Very cool, though. Those are very clearly like based on Allosaurus claws. Those big manual unguals sculpted. Oh, and this is super cool. Is this Ultrasauros right here? Ah, neat. Very cool. When I was a kid, I had this book called An Alphabet of Dinosaurs by Peter Dodson with illustrations by Wayne D. Barlow. And the U page was for Ultrasauros, and it was just a really, really striking painting of this super tall brachiosaur. And the viewer, you're looking up at it like that as these pterosaurs fly by, and it's just wondrous. So Ultrasauros was kind of a newish dinosaur in like the 80s and 90s. Basically like a super large brachiosaur, and that's basically what we now think it is. Just a very, very large brachiosaurus. I think this is the holotype of Ultrasauros. Yeah. The science is originally believed to belong to the genus Ultrasauros, now invalid. The shoulder blade is from the giant herbivorous dinosaur Brachiosaurus, a replica of which is mounted in this room. The dinosaur that owned this scapula was over 65 feet long and could tower 45 feet above the ground. When collected by Jim Jensen at Dry Mesa Quarry in Colorado in 1989, the scapula was believed to represent the largest dinosaur ever found. Wow. Note how many separate pieces are within the specimen. A tremendous amount of work is required to complete a fossil of this size. This is on loan from BYU, just like Supersaurus over there. Ultrasaurus, now recognized as Brachiosaurus, is also there. Imagine the amount of time it would take to put all of this together. And again, this is enormous. That is huge. That scapula is significant. That's got to be, I mean, right here. Lordy, you're what? You've got like a 15-foot wingspan?
Yeah.
Look at that. We're kidding. This thing's got to be, what would you say, 8 feet? Yeah. Like 2.5 meters? Pretty big.
Question about this one.
Yeah.
What's the purpose of the hole in the skull?
Oh, yeah. Right. So right there, that's like a junction between 3 of the different bones on the lower jaw. As mammals, that might seem strange to us because we only have 1 bone in our lower jaw. We call it the mandible. But dinosaurs and other vertebrate animals have multiple bones. There's the dentary right there in the front. That's the tooth-bearing bone. And there's the angular and cerangular, and there's kind of a hole in the middle there. That might have something to do with like jaw, like flexibility. That's also just a weight-saving feature too. Yeah. Dinosaurs are really big into like having different holes in their skulls in order to make them more lightweight and have places for air sacs and hollows and also like flexion. Yeah. What's this right here? Wow. This is one neck bone of a Brachiosaurus. This is the real thing, by the way. So, everybody watching at home right now, humor me for a second, but, feel the back of your neck right now. Just feel your vertebrae right there. And try to imagine a single human cervical vert it's about that big. It's about the size of like a small tangerine, maybe. It's like maybe 3 inches tall. This is one single cervical vertebra of a Brachiosaurus. Just incredible. Again, this was once thought to be from Ultrasaurus, which turns out to just be probably a very large Brachiosaurus. Yeah. Really cool. Got some more over here. There's a caudal vert from a Brachiosaurus. This is one of the tail vertebrae. Pretty neat. And then a Barosaurus caudal vert. This is from much further down the tail, near the end. 2 Barosaurus caudal verts. Pretty cool. And then we'll look at that one again before we focus on our enormous Brachiosaurus here. Yeah. Here is a Supersaurus dorsal vert. Over 52 inches tall. This is one of the largest dinosaur bones ever collected. Wait, this one? No. Not anymore. Yeah. Also on loan from BYU. And this is cool, yeah. The sign tells us to note the deformation here. This would be like a nice symmetrical oval in life. But because this is such a big animal, as it was dead, lying on its side, maybe part of it was crushed just by its sheer weight. And a lot of that is probably also just like plastic deformation from taphonomy, diagenesis, like with the rock layers that used to cover this on top. Would just kind of squish it like that. There was a really cool paper that we discussed a little while ago on this channel about this new big titanosaur from Australia. Honestly, the most exciting thing about that paper, though, were the new methods that were introduced by the researchers. Being able to like kind of undeform big fossils like this in the computer. That is going to be a huge deal, I think, for sauropod research going on into the future. Wish I had a way to share that paper with you right now, but it was really, really cool. Again, sauropods. I've never dug up a sauropod, but I have many friends who have, and yeah, they are a tremendous amount of work, as you can imagine. Even if you just have a few elements like this, even if it's just a few bones, it'd take you a whole summer to dig that up with, you know, a big crew. Yeah. Here, let's check out this Brachiosaurus and we'll continue on to the next room.
Do we have an idea of the weight of such a giant dinosaur?
Something like this? That's a great question. The weight estimates range pretty wildly. Widely and wildly. For a dinosaur like this Brachiosaurus, I've seen estimates going everywhere from about 25 tons up to like 70 tons. And those are metric tons, so like 1,000 kilograms. About 2,200 pounds, if I remember correctly. Yeah. I mean, it all depends. It depends on a lot of things. Like when you're reconstructing the animal, how much flesh do you put on it? Is it really skinny or is it kind of chunky? How dense is that flesh? And all kinds of stuff like that. We don't even really have a great sense for how large these animals were in the first place. For, you know, like how long they would be. So trying to come up with how much they would have weighed is even more difficult than that. But yeah, with any luck, I'm going to have an upcoming project concerning this sometime soon. I'm pretty excited about. I've got what I think could be a cool new method for trying to estimate dinosaur mass like this. And I'm excited to share that when the time is right. But for right now, I'm just marveling at this Brachiosaurus. This is incredible. Just gorgeous. Like, this is...
Izzy wants to know how to
magical.
tell if it's a new species or not.
Izzy, that is a phenomenal question. Paleontologists argue about that all day, every day. You could get 100 different answers to that question if you asked 100 different paleontologists. Yeah, that's really one of the, like, you know, core controversies in dinosaur paleontology right now is how can you tell if something is a different species or if it's something that's previously been named? Yeah. I could go on about that all day, but I won't. Because we have a lot more to see. The last time that I was here, this is at the point that my encoder overheated. Was in this room. I hadn't even gone through. I was like just about to get to the Torvosaurus here when I noticed that the stream had gone dead. So everything you're going to see from this point on is new. At least it's going to be new to you. We're going to move on into the Cretaceous period and see some other dinosaurs. None of them as big as these, but equally as interesting if you ask me. So what do you say we get to it? And what? Quadruple 15 says, which dino fossils would you say are most sure about their accuracy? Like out of all dinosaurs? Something like Sinosauropteryx might be pretty good, because we have full skeletons of it, and we actually have preserved integument. So we even know, like, we know its patterning on its feathers and stuff, because that was preserved. So Sinosauropteryx would be a great example. Yeah, most dinosaur reconstructions are probably... I try to never forget how speculative they are and how much they've changed over the years. We've got a little mirror over there. You know what? I could show everybody the streaming setup.
Yeah, you should.
Yeah. You want to see what you look like right now, chat? I'll show you. There you are. Lordy right there.
Ready?
Yeah. I've got this in order to read chat right now. There's the encoder on the outside of the bag.
Encoder.
Right there. Yep. And then inside the bag, I have my battery pack and a few other things. So yeah. It's a fairly sleek setup, I guess. More sleek than it used to be, at least.
Yeah,
but,
that's great.
Yeah. Shall we continue on? Let's check this out right here. Us and them. What's this about? There's Taniculagrius. And, oh, do these move?
This? Yeah.
Oh, no. Those are just hinges, ball and sockets, and gliding. Yeah. Yeah. We've got ball and socket there, hinge, and gliding.
How accurate do you think the ambiance noises are?
Think the what noises are?
Ambiance noises?
Oh.
Birds and roaring.
Probably
and...
pretty good. I mean, yeah. At Museum of the Rockies, where I used to work, our like dinosaur sounds were mostly just bird sounds that were slowed down, put at lower frequency to make them sound deeper and more guttural. I don't know. It's a lot of this stuff is we just kind of have to guess, you know. Yeah. Man, we need more water on this water feature here. Got these little. These are probably supposed to be Compsognathus right here. Can you find all 13 Compsognathus in this display? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Ooh, there's 2 sneaky ones. Where are they hiding? Behind the cycad, perhaps? Or maybe some of them are just gone now. I would not be shocked if there were some that were mounted right here that have been moved. Yeah, these guys almost certainly would have had feathers. So it's kind of funny to see them. They're painted bright green, presumably because that's what they looked like in the Jurassic Park series. Yeah. These are more accurate reconstructions than in those movies.
What is the most recent dino that we finally got a full skeleton of?
That's a great question. Most recent dinosaur to have a full skeleton from it. There are a bunch that are waiting to be published right now. Those would really be the latest ones. They're like so recent that they're not even out yet. But apart from that, shoot, I don't know. It's very rare to find a complete skeleton. But if you were to just... There might even be one that came out this week that I'm not aware of yet. Yeah, I'm not sure. Alright, so we are walking out of the Jurassic now and into the Cretaceous. Another question, yeah?
If the dinosaurs hadn't died out prematurely and we had the climate changing events, would dinosaurs have died out naturally?
I don't think so, no. I mean, this is the thing, is that dinosaurs existed for about 170 million years, and they survived a lot of climatic changes and stuff like that. It took an asteroid the size of San Francisco to wipe them out, and it didn't even get all of them. It didn't even get the birds. We still have birds today. Birds are theropod dinosaurs, you know? So, yeah, I have no reason to think that if that freak event hadn't happened, you know, like, we wouldn't have lost non-avian dinosaurs. Yeah, I hope that's a good answer for you. There was a paper that came out recently. It's like, oh yeah, dinosaurs were on their way to extinction. I do not agree with that at all. They'd gone really, really strong for 170 million years. Yeah. They're also remarkably adaptable. It's not like they couldn't survive in the cold or anything like that. We had dinosaurs up in the Arctic. We had dinosaurs in the Antarctic. You know, some of them lived in total darkness for, you know, months and months out of the year at such high latitudes, in areas where you would have, you know, ice and snow. Yeah. They're a lot more resilient than you might think. Shall we continue on here? I think this might be the way to go through. Ooh, we've got some pterosaurs right there. Is that Anhanguera? Ooh, I think it is. This is not a dinosaur right here. This is a pterosaur from the early Cretaceous. And they are so weird looking when they're on the ground. I mean, take a look at that, Laurdee.
Yeah.
Just bizarre. Got the humerus, radius and ulna, and then those are their fingers. That's the hand right there. And this is one long finger that forms the wing membrane going up like that.
Oh, weird.
So this is a reconstruction of what it would look like in life. Yeah. It's bizarre animal. But these guys were hugely successful. I mean, these are the first vertebrate animals to evolve flight. And, yeah, even when birds evolve and start doing their birdie thing, these guys hung on until the end of the Cretaceous. Yeah, they were very good at what they did. I love water features in the museum. There's some fishes in there. Super cool. Wow. We've got some Pachycephalosaurus right here. Really, really neat. I wonder how much of these skeletons are going to have to change. I hear the Canadians have a really good Pachycephalosaurus specimen that they haven't published yet. Carrie Woodruff might even be working on it as we speak. But, yeah. Look at how round their torsos are. Again, hindgut fermenters. These guys have really, really simple teeth. Not good for chewing. So all the digestion would presumably take place in their guts. Cool display. Very cool. Those are the biggest of the Pachycephalosaurus, by the way. The biggest ones that we have. Like a lot of things from the Hell Creek, they are the biggest. Is this Utah Ceratops right here? Very cool. It's from a different time than Pachycephalosaurus. But pretty neat. Yeah. Dino Mama, that's very funny. That's a good nickname for somebody who's hard-headed. Pachycephalosaur. Oh, they're calling it Chasmosaurus. Okay, okay. Yeah. So, the funny thing is when you've got ceratopsian dinosaurs, they seem to almost have some kind of smooth gradations from one into another, so that it becomes almost kind of arbitrary where one starts and the other begins. Chasmosaurus is one of those that we might even have an anagenetic series. I found a specimen of Chasmosaurus a number of years ago. Hopefully it's being described and published soon. That should help elucidate some of this stuff. This looks very similar to Utah Ceratops with that parietal bar right there. Pretty neat, pretty neat. Got a little dromaeosaur right there too. With your raptor dinosaurs, like Velociraptor or Deinonychus. That one's probably supposed to be Dromaeosaurus down there. Dromaeosaurus, not a very well-known dinosaur. Still pretty mysterious. And yeah, they're calling it Dromaeosaurus right here. This reconstruction should have feathers all over it. This is way out of date. But yeah, and it says it's poorly understood since only the skull and a few other bones have been found. What was I telling you? Yeah, yeah. Very cool. And Pachycephalosaurus. Check out these guys. Super cool. So as these animals would grow, like these guys don't seem fully grown yet, at least by the shape of the skull. A lot of that is sculpted, but the dome continues to inflate on the top of the skull, and those spikes in the back kind of get resorbed a little bit. They get shorter, kind of get eaten away, almost as if by osteoporosis.
Take two published dinosaurs information.
It can take years, it can take decades. It depends. So some of the people who are going to be publishing on that ceratopsian specimen I found, they have a million other things to do, so it might take them a long time to get to this. I discovered that back in 2012, by the way, so yeah, it's already been, what, 9 years? Like I said, it can take years, it can take decades. So yeah. Let's look at this real quick. Check these out. I love this kind of a display. All of these different skulls of different vertebrate animals. Well, I guess they have to be vertebrates. They're all invertebrate animals don't really have skulls, huh? How many of these can you identify? Let's see in the chat. Do you recognize any of these? I can name almost all of them, I think.
Do we know if the spikes look like cow horns today?
The spikes on Pachycephalosaurus?
I think we're talking about Pachycephalosaurus.
They wouldn't look like, well, they probably would have been much more brightly colored than that. Mammals tend to be pretty dull colored because they don't have color vision. So what use is it for them to be brightly colored? Dinosaurs all had, bright color vision as far as we know. And so I would guess that Pachycephalosaurus spikes they'd be covered by a material kind of like cow horn, keratin, like our fingernails. But they would have been much more brightly colored than a cow horn, I would imagine. Let's see. Rodan says giraffe. There is indeed a giraffe over there, Rodan. This is correct. These are extinct and extant animals. Animals that are long dead and animals that are still around today. Hadrosaur, walrus, yes. Rodan says oviraptor. That is an oviraptorosaur indeed. I think that's Hagryphus, the same oviraptorosaur we saw at the other museum here in Utah. Allosaurus looks like, who is that? Ariops, Schiphactinus, some kind of dolphin right there. That's a Komodo dragon skull. Edmontosaurus, some kind of brontothere or uintathere, Smilodon, an elasmosaur. There might be a stegosaur skull up there. It's hard to see from this angle. Dimetrodon, some kind of peccary. Arctodus, cave bear. Human skull, Pachycephalosaurus. That looks like a pelican skull there toward the end.
What's the fishy thing with all the plates?
The fishy thing with all the plates. Yeah, that's Schiphactinus right there. This right here. Yeah. Schiphactinus. Yeah, sometimes caused Schiphactinus to choke to death. There's a really famous specimen of this animal called the fish in a fish. You can see it in a museum in Kansas or Nebraska or somewhere in that part of the country. But there's a smaller fish called Gillicus in the rib cage of the Schiphactinus. And it seems like Schiphactinus choked to death on this fish. It just got a little greedy, ate a fish that was too big, choked to death, and they were preserved together like that. Really famous specimen. You do not want to meet that fish? Exactly, Izzy. Exactly. Yeah. Pretty neat. All right. We're going to go see some Hell Creek dinosaurs. Yeah. This is my domain. I've done a lot of work in the Hell Creek. So let's see this. Caution, dinosaur tracks. Watch your step, it says Laurdee.
I wear a size 16 shoe.
You have a size 16 shoe? Yeah, so it just shows it. Pretty big. Pretty big. And look at this. Wow. Oh, watch your step too. We've got the pressed penny that commemorates this calls these the dueling T-Rexes. This is funny because this is the same Tyrannosaurus specimen, just two casts of it. Stan and Stan, it looks like, from BHI, Black Hills Institute. It's really sad because this is an example of why fossils belong in museums and not for private sale. This is, a Tyrannosaurus specimen that some paleontologists actually published on. It's been kind of important to Tyrannosaur biology and osteology. And this specimen was sold, I think, last summer, or maybe even more recently than that, for $20 million. So the original is no longer held in a museum. It's basically lost to science now. So that's why you should never publish on commercial specimens. You're just asking to be heartbroken. That's what happened here. There are casts of this that are around all over the place, all over the world now. But the original is now, who knows where it is? I think it was an anonymous purchaser who paid $27 million for it. And man, if I can be a little salty about this for just a second, if you paid $27 million for a dinosaur skeleton, you are getting played. They're not worth that much. I mean, this took a few $1,000s to dig up. and then, you know, a few thousand more to prep and to store and to clean and, you know, consolidate, like all the other stuff. You're dealing with probably less than $100,000, being generous. Yeah. So if you had even $1 million, you could go out and find 5 T-Rexes like this and dig them up, put them on display, whatever you want. So if you buy a dinosaur like that, you are getting ripped off. Anyway, yeah. Got this lovely Triceratops right here. This is a cast, and who is it a cast of? I know I've seen this Triceratops elsewhere before. I forget what this specimen is called, but yeah, I would say this is Triceratops horridus here. You can see by that big old nose horn and the like fairly short brow horns compared to Triceratops from lower down in the Hell Creek Formation. Pretty cool. Big barrel-shaped rib cage. These guys have big torsos. They've got such big heads that you forget how big their torso is too. I mean, look at that. Look at that. And the ilia on the back, they're basically just forms this giant shield over the back of the hips. Pretty cool. Pretty cool.
Does that mean we know where tons of fossils are? We just haven't bothered to dig them up?
Yeah, I mean, like we have many places here in North America, you know, in Utah, Colorado, Montana, Wyoming, where we know that if you go out and look, you will find dinosaurs there. We just don't have enough paleontologists, and we especially don't have enough funding to be able to go out there and find them. So there are lots and lots of fossils that are just sitting out there, being weathered, just eroding to dust, and they'll just be lost forever. We need more paleontologists, we need more volunteers, we need more funding. Because the stuff is out there, and we know how to find it. We just don't have the resources for it, you know? Yeah.
Henny's wants to know, does ontogeny slow down speciation?
Maybe, Annie's. That's a great question. That is like a doctoral thesis
I was gonna say, that's a
quality
high-level
question right there. Yeah, super high level. Yeah. There are people working on that right now. That's all I'll say. We've got these lovely ostrich dinosaurs. We saw one of these yesterday, Laurdee, at the museum in Salt Lake. But it's cool to see them like we were looking down at that one from that causeway. It's neat to look up at one. These are such big, impressive animals. Ostrich dinosaurs, the ornithomimosaurs. Really cool. One thing I want to point out to you, and we actually have a golden opportunity here, that we have an ornithomimosaur and a tyrannosaur mounted in the same space. Check out these metatarsals right here. So in Saurischian dinosaurs, this is kind of rare. This is what we call the arctometatarsalia condition. Arctometatarsalia condition. Where the metatarsal bones are all fused together like this into like a single shock-absorbing mass. You've got 3 bones. Maybe you can just see the right here how they're kind of pinched together into a solid mass like that. This seems to have evolved to, you know, help these animals run. It's like shock absorption. So ornithomimosaurs, the ostrich dinosaurs behind me, might not look super similar to tyrannosaurs like these guys, but they are pretty closely related. I think outside of Tyrannosauroidea, ornithomimosaurs are like the closest relatives to these animals. And so right here, you've got that same thing going on. You've got those metatarsal bones all fused together, just like that. So the one in the middle is just being pinched by the ones on the sides, just gets squeezed out into a little splint. So you've just got like this solid mass right there. Really cool. Really cool. Just trying to give you another view. This is an impressive mount right here. It's pretty neat. The teeth, by the way, standard disclaimer, these teeth are wrong. You see how they're really, really long? There's like a kind of shiny black part up top, and then there's like a duller brown part underneath. The duller brown part is the tooth root. These teeth have been pulled out extra far. I don't know why. Maybe to make it look more scarier. But yeah, so these teeth are too long. It should just be the black part protruding out of the jaws there. Well, look at how small these arms are here too. About the size of my arms, maybe a little shorter. And then we've got this unfortunate little duck-billed dinosaur, juvenile Edmontosaurus. Didn't even stand a chance. Poor thing. Oh man. We get some F's in the chat for our Edmontosaurus here. Oh man. You're right, that does put things into perspective, right? Yeah. Look at those arms. Imagine your arms on an animal 40 feet long. Yeah. You were saying, Lourdee?
Tropical says, what about the gums?
What about the gums? Yes, these dinosaurs didn't really have, like, gums like that in the way that you think of them, I guess. I mean, they had some soft tissue there, but not like mammal gums. It would be distinctly different. Think about like in a crocodile's mouth. I mean, I don't know if you could talk about gums on a crocodile. I don't know. Yeah.
Is it because the teeth renew regularly that they seem to have random sizes?
That's part of it, yeah, for sure. So we'll look over here at this lower jaw there and up at the upper jaw too. You see how there's like just a little tooth kind of peeking out there? That is a tooth, being replaced. And so a lot of these dinosaurs would have had kind of like a snaggle-toothed smile because they're constantly losing teeth and replacing them all the time. Yeah. I hope that makes sense. Again, I don't know if maybe the skull was found with the teeth all loose. Maybe the teeth were not embedded in the jaw when it was found. Or maybe the folks at BHI wrenched the teeth out in order to make them look longer and help sell casts of it. I don't know. But at any rate, those teeth in there are too long. It's a beautiful mount, though. I always thought Stan had really nice hips, too. I wonder how much of that is sculpted.
Would female T-Rexes have any different morphology? Maybe the arms were just for mating.
Like females wouldn't have arms? We've never found a Tyrannosaurus without arms, at least. We found them without arms, but because the arms were missing. Because the skeletons were incomplete. There have been a number of different paleontologists who've tried to find skeletal differences between males and females. There was one idea, actually put forth by BHI, by Pete Larson, I think, that the caudal chevrons would be different on males and females. Sorry. That those little bones that hang down from the tail, those are called the caudal chevrons. And there was an idea that in males, the first one would be longer than in females, that it would be an anchor point for the male reproductive gear. That doesn't seem to be the case. That's not really held up to further scrutiny. So as far as we can tell, there's no real difference to tell. There's no real way to tell the difference between male and female Tyrannosaurus or really any other dinosaur just by looking at their skeletons. They don't seem to be sexually dimorphic osteologically. The skeletons of males and females seem to be pretty much identical. Maybe they differed in size, like in birds. But yeah, it doesn't seem like their bones are really any different between male and female. Except internally. So the first dinosaur to ever be demonstrated in a peer-reviewed journal to be female was B-Rex at Museum of the Rockies, a T-Rex specimen. She was found to have had medullary tissue in her bone. This is what female birds produce when they're about to lay their eggs. So found it in T-Rex, according to Mary Schweitzer at least. She found it in a Tyrannosaurus specimen. So she had the very first like definitive female T-Rex. But it was just the interior of the bone where you could tell. Nothing exterior indicated that this animal was female. Did you have a...
There's Cubits asks, and they might be new. Where are the young dinosaurs?
We have a few around here. It's funny asking that question. That's a question that paleontologists asked a while ago, because we didn't really have many examples of young dinosaurs, because it turns out people had been finding skeletons of young dinosaurs for years and then just naming them as new species, rather than recognize them as being juveniles. Here we've got a younger Edmontosaurus right here. This lovely duck-billed dinosaur. These guys could actually be the largest dinosaurs in the Hell Creek Formation. They got even larger than T-Rex. Here's a fairly young one right here. A little bit smaller. You know. It's about the same height as me, if I were standing on the same platform. And here's an adult right here. It says, "Please do not climb on exhibit." I'm going to follow that advice, but you know I was tempted. Edmontosaurus. Yeah. No, but it's funny that you ask about juvenile dinosaurs. This is a huge deal in dinosaur paleontology right now. It turns out that a lot of the dinosaurs we used to think are like different genera or different species. Turns out they're just different growth stages of the same dinosaurs we already knew about. So yeah. We're starting to see some consolidation of different dinosaurs in a few areas. There's new ones being discovered in new places and new times, but some of the dinosaurs we've thought for a long time were different. You know, like Stygimoloch, Dracorex, Nanotyrannus, and Natotitan. All dinosaurs from the Hell Creek Formation we now see as ontogomorphs of previously named dinosaurs. So yeah. This is funny that this is in the same display here. Utahraptor is not from the same time or the same place as Edmontosaurus. Utahraptor is from like the beginning of the Cretaceous, Cedar Mountain Formation of Utah. Edmontosaurus is from like the end of the Cretaceous. But anyway, this just gives you a good sense of scale for this dinosaur. The biggest dromaeosaur we know about so far, as far as I know. Yeah, pretty cool. The biggest dromaeosaurs, the biggest dromaeosaur ever found. Pretty neat. Pretty neat. We just have a random hadrosaur skull here, unlabeled. Pretty cool. Pretty cool. That's pretty neat. Oh, and here's a genuine Triceratops skull. Very nice. Can you make heads or tails of this, chat? I can interpret it for you if you'd like. There's the nasal horn right here. This is Triceratops prorsus, so this is from the top of the Hell Creek Formation. You can tell just by the shape. It's got this big pointy nose horn, projects forward like that, pretty robust at the base. Here's the nares. This is the nostril right here. And here's the orbit, the eye socket. It's got these pretty stocky, short brow horns. It's characteristic of Triceratops prorsus. Again, we've got so many different specimens of Triceratops nowadays that we can basically watch them evolve through time. Super cool stuff. So I can just tell by looking at this is a Triceratops about 66 million years old. This is like right before the extinction event takes place, when the big asteroid hits the Earth. And this is a hands-on exhibit, so you can actually touch that. Pretty cool.
Oh, it's so old.
I know, it's 66 million
That's
years
so
old.
cool. It's really cool that they put these things out, because it's like, as a kid, like, these are the things you remember.
Exactly, yeah.
It's like things that you can touch and feel, yeah.
Imagine, like, going to this museum during a school year on a weekend and then going to school on Monday being like, oh, I got to touch a real dinosaur bone over the weekend. Telling your class that would be super cool.
Mikey Lex wants to be reminded, what dinosaur did they wrongly call Velociraptor in Jurassic Park?
Oh, that was Deinonychus. Yeah. It's a long story, but the Velociraptors in Jurassic Park are actually Deinonychus. Although even in the movie, they're a little bit too big for Deinonychus, but yeah. We've got a cool cast of a pterosaur skull right here. Chupuhuara. That's one of the tapajarid pterosaurs. Look at that crazy skull. There's the beak right there. Big old nares. So the nostril is probably like at the very end of that. Right over there. And there's the orbit, the eye socket. It's funny, when you look at pterosaur skulls like this, you have to imagine that at least part of what's shaping their evolution is aerodynamics. I mean, you're an animal flying through the air and you have this huge head with this big old honking crest on it. Like, it's gotta be that when you turn your head as you're flying, it's gonna change your direction a little bit, I would imagine. Just imagine the amount of drag that would have if you turn your head sideways really suddenly. Interesting to think about. Yeah. And was it Dino Mama was asking about baryonyx? Somebody was asking about baryonyx earlier toward the beginning. Yeah. Well, Dino Mama, was it you or somebody had a viewer watching right now who's interested in baryonyx or Suchomimus? There you go. This is the skull cast of Suchomimus. This is one of my study animals, Lourdee. This is a Spinosaurid. Look at how long and narrow those jaws are.
It's really notable.
Yeah, yeah. And I've seen casts of this animal. Oh, big parts of this are speculative. So the parts that are actually represented in the real fossil are like the tip of the premax right there and the nasals. But a lot of the stuff that's really smooth looking has been sculpted. So only a few parts of this we actually know of for sure. I've seen reconstructions of this same skull where it's even thinner and more strappy and you know, kind of more elongate, you know, just more skinny overall. This is a fish-eating dinosaur. Spinosaurids like this evolved to eat fish. And one of my ongoing research projects is trying to determine how they would have caught fish using things like these really elongate jaws and these cool, non-serrated, crocodile-like teeth, very conical teeth. And these, especially, these super robust forelimbs. Really, really heavy forelimbs like this that would have been probably really muscular in life. And look at the size of those claws. Just crazy.
How do they know that the skull wasn't just crushed during fossilization?
Well, yeah, because we've seen a lot of skulls that are crushed during fossilization, and it looks a lot different. Like here, you would have to crush it and also stretch it way out. And we can tell that this is not a really heavily crushed skull. It's not cracked, it's not smushed. It's just that's how it is. We have other related dinosaurs from around the world, other Spinosaurids, that show us the same pattern. So we know that this is something, you know, inherent to the biology of the animal. This is not something diagenetic. This is not something that happens, you know, during burial and fossilization and all that. So yeah, pretty cool. This is my favorite dinosaur in this museum. So I'm really happy to be able to show it to you. Yeah. It's not every museum where you get to see a Spinosaurid on display. Even a cast, but yeah. Super, super cool.
Nana Tyrannus says thanks for the birthday wish.
Oh, yeah, Nana Tyrannus. Happy birthday to you again. So glad you could tune in. I'm sorry I couldn't catch you on the phone earlier. I left a message. I'm explaining for everybody else. You already heard the message, Nana Tyrannus. But I hope you're having a great day, and I've been thinking about you. It's August 4th. It's Nana's birthday. Never forget. Yeah. Suchomimus. Man, this dinosaur was kind of the key to several of my findings in this upcoming paper. So, I don't know, this is an animal very near and dear to my heart. It's definitely got a special place right in here. So it's awesome to be able to see it. Very, very cool. And you can see why, like, parts of these guys, especially their teeth, had been mistaken for crocodile parts way back in the day. Yeah, really neat. And here is a... Yeah, I would draw this animal a lot differently from what you see here, but yeah. Just give you a broad sense for what this would look like. Yeah. And what do we have here? We've got some clams from the Frontier Formation. I wonder if that's the same Frontier Formation in the early Cretaceous that I've worked before. Looking at dinosaur tracks. That's cool. These are about probably 130 million years old, something like that. Some clams. Yeah, and then we've got some little psittacosaurs over here. Check these guys out. Very cool. Lodi, we were talking about Psittacosaurus yesterday. This dinosaur.
They're pretty cute.
I know, right? Lovely skull. So this is an ancestor, or yeah, this is at least closely related to the ancestors of the big ceratopsians, the big horned dinosaurs. So like the horned dinosaurs, like Triceratops that you know and love, these guys also have a kind of parrot-like beak in the front, and they've got those jugal spikes. Their cheeks flare out and form these spikes right there. Right there. And on the other side too. Right there. But they don't yet have the horns or the frill that characterize some of these later ceratopsians. And these guys are either facultatively bipedal or even fully bipedal. We don't really know yet. But like I was saying, most dinosaur groups start off bipedal, and only later do they develop, walking on four legs. These guys could probably do either. But yeah. And they would have evolved into, over tens of millions of years, into the big ceratopsians, like our Chasmosaurus back there. Oh, and Confuciusornis, very cool. Very, very cool. This is a cast of a really important Mesozoic bird, a bird from the age of dinosaurs. This is one of the best known Mesozoic birds found in China. It's like right there on the cusp of the Jurassic and Cretaceous periods. Pretty neat. And I love that there's the bulletin right there from AMNH. This is from the American Museum Novitates, which is their in-house journal. Very cool. Oh, this is actually one of those few times when we can maybe tell a dinosaur male from female. It's a bird. It's a lot easier to tell birds, males from females, because they often have different feathers. This is the case here. Confuciusornis, sometimes they have these long double feathers coming off the tail. We've got so many specimens of these animals, it seems like half of them have those two long tail feathers, and half of them don't. There could be males and females. I don't know if we really know that for a fact, but it has been brought up in the literature a few times, and it would make sense. All right, and let's get a closer look at those pachycephalosaurs. Right here. Super cool. They almost look like they're running at each other to butt heads. We no longer think that they did that. You've probably seen that in the movies or in kids' books. These guys ramming their heads together like bighorn sheep. It's kind of an old idea. I don't think anybody really buys that anymore. Maybe they would have used those thick heads, as defense against predators sometimes, but they don't seem to have evolved for that purpose. That dome doesn't actually really show up until later in the animal's life. So usually animals are most vulnerable when they're young. And so to not have your chief weapon there when you're at your most vulnerable doesn't make a lot of sense. So that dome was almost certainly for display. And given the fact that it seems to grow really, really quickly, and like almost in kind of a almost in kind of a sloppy way. Like the bone inside, it's not hollow, but clearly it's really spongy. It's just growing really, really quickly. Not great for shock absorption or anything like that. Yeah, pretty neat. And oh, Bambaraptor right here. This is a juvenile dromaeosaur. This is one of those cases where somebody found a young animal and they gave it a new name. I don't know if we have an adult though. According to the rules of zoological nomenclature, you're not really supposed to name an animal based on an immature specimen. Well, that's what they did here. Yeah, so this is a cast of Bambaraptor, this little dromaeosaur. We saw some of these elements at the Museum of the Rockies too, including that little furcula, the wishbone there. I think we saw the original there. But yeah, very, very bird-like. In life, this animal would have feathers all over its body, just like a bird. It's like a little mini velociraptor. And look at the tail. See how it looks all scrunchy like that? It's just got these tendons running down the tail to stiffen it. The base of the tail is flexible, but basically the rest of it is like, it's like a broomstick, really stiff. And there's a reconstruction of what the animal would look like in life. Yeah. And may have even been feathered. We now know these animals. All dromaeosaurs we think were fully coated with feathers, just like birds. Yeah. Pretty neat. Earlier, I think there's that room over there. I think that's where we want to go.
Yeah, I think this just goes back to the water exhibit.
Yeah. So let's head off in this direction. We will see some marine animals from a Cretaceous ocean. That's probably where we'll see more Schifactinus, maybe some elasmosaurs and mosasaurs. Yeah, we'll see what we can see. Walking back through here again. Just want to take a minute to appreciate these Tyrannosaurs. This is a very dramatic display. I mean,
look at this. This claw is the size of my hand.
I know, right?
This claw is the size of my hand.
It's huge.
It's huge.
Just amazing. And look at this. I love the blue light in here. Look at that. Check this out. Is this Archelon right here? Giant turtle?
Question, did dinosaurs migrate based on food or weather?
Almost certainly, yeah. I mean, if you think about the big sauropod dinosaurs that we saw, imagine how much food those animals would require. They probably had to be on the move all the time just to be able to feed themselves. You kind of wonder how plants would have dealt with that. Yeah. And you know what? I see we just missed something. Let's go back and check out that Protoceratops on the ground real quick before we go in here. Yeah. There we go. Aww. This is life size for a Protoceratops. Beautiful. It's beautiful. I love the eyes on there. Cool. Just out here lounging. Oh man. Wish you were here, everybody. This is a lovely little touch just to have this here. Beautiful animal. All right. Oh. And let's check this out real quick too. Form and function. Hey, Lourdee, you know this fossil right here. Without looking at the name, what's that?
It's Archaeopteryx.
Archaeopteryx, yeah. Pretty cool. So, I know in places like Utah, sometimes people are a little bit reticent to discuss the idea of evolution. This is kind of a way to talk about evolution without talking about evolution. Form and function. Yeah. Gorilla skeleton, Archaeopteryx, set out. Harpy eagle. Look at the claws on that harpy eagle. Holy moly. So these are eagles that will swoop down out of the sky and they will capture monkeys or sloths. And they'll basically like crush their skulls using their feet.
Wow.
It's incredible. Look at that digit 1. Look at how thick that is. Just nuts. Look at how thick that bone is. That phalanx there. That is the... They could probably crush your skull if they really wanted to. Yeah, nuts. Here's Ingenia. This is an Oviraptorosaur dinosaur. And look, these guys, Oviraptorosaurs seem to love shortening their tails. We've got some genera like Nomingia. Is it Nomingia? With the Pyga style? I think it is. Where, yeah, the tail is just like a little nubbin. Pretty neat. Got that cold toothless beak.
Explain the star-like structures on the Archaeolon.
Oh, on the Archaeolon? Sure, we will do that. Yeah, let's go ahead and move on into the Western Interior Seaway here. As dinosaurs were running around doing their thing on land, sea levels rose in North America, kind of splitting the continent in two. You ended up with this big inland sea with all of these weird and wonderful animals inhabiting it. My goodness. So cool. This, of course, is Archaeolon. So, this is, I think it might still be the largest turtle that ever lived. Just astonishing. Leatherback sea turtles today are pretty big. They could be like the size of a small car. This is like the size of a large car. Archaeolon. The largest turtle ever found, according to the signage. Its name means ruler turtle or king turtle, yeah. Like archosaurs, the ruling reptiles. Archaeolon. Ruler turtle. Pretty neat. So these bones along there are osteoderms that are fused onto the rib cage. So a lot of turtles will have these osteoderms, the bones that make up the plastron and the carapace, that are kind of star-shaped like that. They've got these finger-like projections. Trinychid turtles are like this too. There. And so, like a leatherback sea turtle, these guys, their shell is not completely enclosed, by bone. A lot of hollows in it. And like leatherback sea turtles, I would imagine these guys are probably endothermic. Like they probably generate their own body heat just by virtue of their size and, moving their muscles. Yeah, pretty cool. Just imagine being like, sitting under an umbrella on the beach and then seeing this thing come out of the water. Big female Archaeolon to go lay her eggs. Just watching her haul herself up onto the shore. I mean, that would be incredible. It's amazing enough when you see a modern turtle do that. Imagine something this big. These guys may have been like approaching maximum size for how big a turtle can be. Like still being able to support their weight on the beach when they go to lay their eggs. Yeah, very cool. We've got some other turtles in here. Toxicales.
Look at this one, bro. How cool is that?
A mosasaur right here. These giant ocean-going lizards from the Cretaceous. This is probably a Tylosaurus right here. It's one of the biggest of the mosasaurs. Just incredible.
So wouldn't there be for them on land?
Yeah, and that's my point when we're talking about turtles like this. Because the bigger you are, the heavier you are, and your mass goes up It's not like the square cube law or something like that. So maybe this is like the maximum size that you can be a turtle moving on land before you're just too heavy. It doesn't work anymore. Yeah.
Do they know if Archelon had a mouth like a leatherback turtle?
I don't think we know. Yeah. I'm not sure. The skull certainly looks different. It's got like a, you know, and I don't know if we actually have like a complete Archelon skull either. Yeah, that looks pretty legit. This doesn't look like a sculpt. Yeah. Yeah. Huh. I'm not sure. I really don't know enough about Archelon. Yeah. But man, this mosasaur, this is the biggest mosasaur I've ever seen in a museum. This is nuts. That skull is like 5 feet longer. Crazy. And Spinobreaker, I don't think we have any turtles that gave birth to live young today. So I don't think there's any reason to think that Archelon would have done the same. That Archelon would have given live birth. Yeah, I think they almost certainly laid eggs. Could be wrong though. I'd love to be proven wrong. And here's an actual mosasaur
This
fossil.
is Laura during Jurassic Park.
Feel the
Digging
teeth.
up dinosaurs is hard, frustrating
African.
work. It takes months or years.
Smaller than this guy.
So leave it to the
Holy
professionals.
cow. Top predators in their ecosystem.
How beautiful this is.
Yeah. Holy cow. That's real too. That's the same genus that we saw at Museum of the Rockies. That same mother of pearl. It's just gorgeous.
For everyone, I am Purelling. Chat's been concerned.
Oh, okay. Yeah. Yeah. Here's a smaller mosasaur right here, Clydestes. I'm taking it on good faith that mosasaur researchers have done their due diligence and they know how to tell a Clydestes from a juvenile Tylosaurus, but yeah. Yeah, this one's about Komodo dragon size. It's got a bigger head. These are basically what those animals are. These are like giant marine varanid lizards. I think it's still kind of controversial whether they are varanids themselves or whether they're like a sister group. But basically picture these guys being giant monitor lizards in the ocean. Flippers instead of limbs. This long, snaky body. Look how far back the tail goes. You just lose it behind the corner there. Yeah. Super cool. These ammonites right here. It's weird to see the eye like poking up out of the top like a frog. I wonder how...
Is this the baby mosasaur here?
This is a different genus of mosasaur called Clydestes. But...
Is there a baby mosasaur? I was asked to take a picture of a baby mosasaur.
Oh, that's probably this. Yeah.
Okay.
I think this Clydestes is close to full grown. Again, I'm taking it on good faith that mosasaur researchers have done their homework and they're not just naming small mosasaurs juveniles as new species or anything. Yeah. I guess those are supposed to be Placentaceras back there. That same ammonite that we just saw, the super shiny one. All fleshed out. Yeah. Yeah, Lane County, Kansas. Again, this is what the middle of the country looked like during the late Cretaceous period, about 90 million years ago. Super cool. Really neat. Got some beautiful fossil fishes. Guitarfish, stingray, drumfish, herring. We've got some invertebrates like shrimp and squid and lobsters. These are all real, by the way. Or they look real, at least. Very cool. These are from Lebanon, apparently.
Benny Hill sub for 13 months.
Benny Hill, thank you so much for your ongoing support. That means a lot to me. Holy cow. 13 months. It's a year and a month there.
It's also getting a little pixely back here.
It is? Okay. We're probably not getting great signal here. This is really weird. Big baculite. It's like a giant squid in a cone, basically. And then, what we're looking at right here is an elasmosaur. Check that out. Holy cow. Just look at that. Beautiful skull, but all of those vertebrae there. I'm tempted to count them, but it would take too long. Just look at that. Why in the world would you evolve such a long neck? Like, why is it that important? Just nuts. Nuts. What are these guys doing that they need such a long neck like that? I don't know. I don't know what the current consensus is on elasmosaurs. I just know that they are amazing. And they are one of my favorite non-dinosaurian Mesozoic creatures. Just astonishing. Huh?
I think that when you're panning, it's cutting out for them.
Oh, really?
Yeah, because it's just pixely.
Okay. Well, let's continue on this way. There's a sawfish right there. Really cool. Or it looks like a sawfish, at least. Check out this Trifactinus, Laura. Look how long it is. Just look at that. Crazy, crazy, crazy.
It got a lot better.
Got a lot better? Okay.
Pan to your heart's content.
Great, 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 great. Yeah, again, look how long that mosasaur is. Just nuts. This is such a cool room. This is a display about the end of the age of dinosaurs. Mass extinction event. The impact of that asteroid. And then, of course, after the extinction of the dinosaurs, begin the age of mammals. Like how the lighting changes. Yeah. It's funny, briefly dinosaurs make kind of a comeback in the form of big flightless birds like this Diatryma. I think most paleontologists now call it Gastornis.
This is an earlier bird.
Yeah, so this is a bird, so basically like...
this is descended from dinosaurs.
Yeah.
Okay.
So it's like there's all these open niches after the non-avian dinosaurs go extinct, and mammals are still pretty small for a long time. This is an early horse right here, Propaleotherin. And so it kind of takes mammals a while to get really big, and in the interim, like, birds kind of fill some of the big predator gaps. So yeah, you've got these big terrestrial flightless birds that are, it's kind of like they want to be big terrestrial theropod dinosaurs again. Although, I want to say that Diatryma and Gastornis, these big birds like this, more recently, researchers are leaning toward the opinion that these guys are probably mostly plant eaters. You see all kinds of illustrations, older illustrations of these guys, like chasing down and eating small ancestral horses. It's like a classic trope in paleo art, this Diatryma eating little horses. They maybe didn't do that. These guys are very closely related to, well, out of all the groups of birds, they seem to be closely related to like Anseridae, like ducks and geese. Yeah. Yeah. Diatryma. This huge bird was the dominant carnivore wherever it lived. I think we're not as sure about that as we used to be. Yeah. Yeah. And then, of course, we've got some ancient mammals. We will see some uintatheres when we go to the museum in Vernal, and some brontotheres. There's like a giant pig-like creature, basically like a giant pig from hell. Megacaris. It's an entelodont. Really cool.
And we've got an early horse being preyed upon by an early saber-toothed cat. Hoplophonius, apparently, is the name of that cat. And a mini saber-toothed cat.
Right there. Yeah.
Man, those teeth. Yeah.
So, Quick 5, we're almost done here. So if you want to stick around, yeah. We're not going to spend too much time around the mammals, because, I don't know. I love mammals, but, yeah. This is really cool, though, Lord. I want you to see this. That looks like a saber-toothed cat, right? Right there, like with the big Jay Leno chin on it. That's not a cat at all. That's a marsupial. So in South America, marsupials are kind of having a heyday during the Age of Mammals, when North America and South America were still split before they joined at the Isthmus of Panama. And marsupials evolve into all kinds of different shapes and sizes, including something that would have looked like a saber-toothed cat. But it had a pouch, like an opossum or like a kangaroo. It was a saber-toothed marsupial. Thylacus milis. Super cool. From the Miocene of Argentina. And you've got various other saber-toothed cats that evolve. Saber-teeth evolve in cats multiple times. So I think it just kind of keeps happening.
Dark Raven asks if there's a Nimravid.
Nimravid? I don't know if we have any Nimravids here. I don't think so. Those are the carnivorous marsupials from Australia, right? I don't think we have any here. This is an ancient rhino. Pretty cool. There's a weirdo elephant, Platybelodon.
Check that out. These are called shovel-tusker elephants.
Because they've got, big shovel tusks right at the front. On their lower jaw. It's like an early camel right there.
Stenomylus, yeah.
So, I talked during our zoo stream at Zoo Montana about how camels first evolved in North America, and then they went extinct here, just like horses. Yeah. So that's an early camel from North America. And here we've got a glyptodont
without its armor shell. Usually these guys, they got this big armor shell on them. Maybe this guy was found without it, or I don't know. Yeah.
That's part of the animal. It's not like they could just walk away without it.
Being accosted by this Smilodon saber-toothed cat. Pretty cool.
There's an American lion skull up there, Felis atrox. Yes, we did once have big lions in North America, not just mountain lions, bigger ones too.
Here is a weird pygmy elephant. Are these from the island of Crete, I think? Islands in the Mediterranean Sea. So,
this is a really interesting story. So, elephants, one of their primary defenses is their size. They're hard to take down by predators because they're so big. But when there were populations of elephants that were isolated on islands in the Mediterranean where they had no predators, suddenly they didn't have to be so big anymore. And so they evolved smaller sizes. And they
seem to be about this big.
So, again, not a big animal. Pygmy elephants. And this happens multiple times. When elephants become isolated, when they don't have predators anymore, they get smaller. So it just shows you how important size is to, as a predator defense for elephants. Yeah.
Aren't American/cave lions placed in Panthera?
What did I say before? Felis atrox? Maybe they have been reclassified, I'm not sure. I know that cougars, that's mountain lions, pumas. That's Felis concolor. That's the same genus as house cats. I think the American lion Panthera atrox is, I think it is like a true lion. Yeah, same genus as today's lions. Panthera leo, I think, is the Latin binomial for the African lion. Yeah.
Kate wonders, how do you know it's not a juvenile?
Which one?
I'm assuming
Oh, for this?
this latest one.
Because they found juveniles too, and they're even smaller. Yeah. Also, these guys, like, they've got really weird.
It's like a dachshund version of an elephant.
It's like a wiener dog elephant. Yeah. It's weird, really weird. There's a woolly rhino skull, a dire wolf, oh, and a giant beaver, Castoroides. Super cool. And then,
You know, those weren't babies, Fail.
and is this Megatherium up here? I think it is. A giant ground sloth. We've seen some Harlan's ground sloths on this trip so far. Paramylodon. This is... Oh, Eremitherium. Okay. Yeah, so I guess it's not... This is not as big as giant ground sloths get, but it's still really big. Check that out. It's a sloth the size of... It's like bigger than a rhinoceros. Very cool. I love this pose. This is so neat. I know, right?
What a weird looking skull. Holy cow.
So, is the nose skull part broken off, or is
No, it's just...
that was fleshy?
That's just fleshy, yeah. A lot of mammals are like that, where like look at these guys right here.
I've seen a lot like that.
Yeah. That part would just be fleshy. This too. Yeah.
We'll look at the rhinoceros skull and you can see that even more. Yeah. Yeah, weird. Mammals are weird. We are weird. Here's Coelodonta. It's a woolly rhinoceros. And again, like all the lips and everything on the front and like the front of the snout, it's just not represented there by the bone. Part of that is broken, but part of it is just not there too. Oh, I forgot about this. I hope you all like sharks. If you don't, you might want to sit this part out. But got a pretty big shark here. This is a reconstruction of Otodus megalodon. Megalodon shark.
Pretty big. And this is...
It's still a controversy how big these sharks actually could get. This, I think, is a modern white shark right here. This would be a big one, too. About, I think, 20 feet long is about their maximum size. This might even be slightly larger than that. But these guys, there have been estimates going from 35 feet up to like 80 feet to 100 feet for megalodon sharks. We still don't really know how big they got because their skeletons don't fossilize very well. They've got big teeth and they've got big vertebrae, but like until we find a really good, length of vertebral column associated with some teeth, and until we find some really good specimens like that, it's hard to really put a good, to really say for sure how long these things were. I actually have a YouTube video about that from a long time ago. You can check that out if you want. Yeah. Pretty neat. Got a dolphin specimen right here. Beautiful cast of a dolphin. Dolphin skulls always look so sinister.
Fossilized well. What's the difference compared to the other types of bones?
Well, so sharks are elasmobranchfish. They have cartilaginous bones. So their bones aren't made out of the same stuff that our bones are made out of. They're made out of cartilage. Cartilage doesn't fossilize as readily as regular bone. Their teeth fossilize super well, and they produce a lot of them over their lives. So we've got tons and tons of teeth from these critters. we have like hardly any preserved vertebrae, and the ones that we do they tend to be isolated. If you want to determine how long a creature like this would be, you'd have to find a good series of vertebrae so you could actually measure it. And yeah. Anyway, pretty cool. Got some lovely sawfishes up there too. Very neat. All right, we're almost done here, Laurdee. Getting into the places scene here.
Okay.
And
I see some humans.
yeah, you know those.
Now we're getting towards the end. Yeah.
Yeah. Let's go by some of these beautiful invertebrate fossils real quick. These are from California. Very cool. Almost identical to modern taxa. Some very nice gastropods in here.
Nice little crabbies.
Look at those. Exquisite. Just beautifully preserved.
Really beautiful. You can see I don't know if you guys can see, but you can see the texture even on the shell.
Yeah.
Just an incredible specimen.
Amazing.
You almost don't want to get close to them. I think they'll pinch you.
Got some sand dollars in there. Very nice echinoderms.
What are these? Turritella-like marine snail shells. Cerethium giganteum. Take a look at that.
Imagine the snails that would inhabit those. Just huge. Enormous. That's so big. Alright, and here, what are these bizarre creatures?
There we go. Is that a Colombian mammoth or probably Colombian mammoth?
It just says Mammuthus. Not Mammuthus primigenius, not Mammuthus
Species
Columbia.
primigenius.
Oh, primigenius. Okay, woolly mammoth. Yeah. I didn't look as robust as the Colombian mammoths we've seen.
Avocado wants to know, what are those bizarre creatures destroying the planet? Yeah.
Some of them being destroyed themselves.
F's in the chat for that guy. No, you win some, you lose some. Poor mammoth. And this is cool. I get questions about this all the time. So this is like ancient Greek culture.
I like this sentence, that they interpreted fossils according with their understanding of the world.
Yeah. Ancient Greeks found mammoth bones and considered them to be remains of giants, such as the one-eyed Cyclops. I don't know if we know that for sure, but it is a popular idea. There's a great book about this. If somebody types in !mythology, I have a command for that. Those mammoth teeth, just nice and flat.
Yeah. There's a mammoth skeleton painted on the wall, and a reconstructed Cyclops skeleton.
Made from the same bones. Oh, and check this out. This is life size here, Laurdee. Apiornis, the elephant bird. Check that out. This is life size. And there's the elephant bird egg.
Is this the one that you have?
This is the one that I have back in my office.
Yeah. It's about the same size, too.
Yeah. So these
This
birds.
is life size.
This is life size.
That's crazy.
These
I didn't
lived
remember.
alongside
that
people.
That didn't occur to me.
Yeah. Like 10. Well, I mean, you're what? 11 foot
9
8?
foot 10.
Yeah. So that bird's twice as tall as her. No, I'm just kidding. This bird's like 10 feet tall, like 3 meters.
Even 11. It's tall.
Yeah, really impressive. And these lived alongside people. This is megafauna that, you know, we think that these guys probably went extinct about, what is it, like 11,000 years ago in Madagascar? Because people kept eating their eggs. And maybe hunting the adult birds too. But yeah, a big egg like that, you could see why ancient people would want to eat it, but unfortunately they drove this magnificent animal into extinction. Yeah. Beautiful, beautiful creature. What I would give to see one of these things alive. I mean, imagine that. Being able to see an elephant bird in the flesh. Incredible. And people saw them. Yeah. Here is a baby mammoth.
This is real.
Yeah.
Real skeleton.
This is real. Real bone right
fossils.
there. Or,
Or maybe it's screwed in and just armatured around it.
yeah, no, this is a cast. But yeah.
Okay. It's a nice looking cast.
Yeah, it is. It's painted really well. Yeah. Baby mammoth. Or if you're a dinosaur paleontologist, oh, new species. I'm just kidding. Yeah. It's adorable. So cute. Yeah. Very cute. All right, we will continue on from here into here. There we go, talking about extinction. Endangered species in Utah. Sobering stuff.
Who do you think will take over once the humans are gone?
I don't know.
Try not to think too.
Once
too far
humans
ahead.
are gone, it depends how we go.
Depends what happens.
Yeah.
How that plays out.
Maybe rats, maybe raccoons.
I
It's gonna be
think it's dolphins.
dolphins.
Yeah.
Dolphins are already having trouble. I don't know.
Yeah. I just like them.
Who says it has to be just one species, though? You know.
Yeah.
Anyway, we're gonna continue on through here. Kids' play area. All right. And there we go. That was the Museum of Ancient Life here in Lehi, Utah.
Wanna pop us go out over in the cafe or?
Yeah,
on the
or
bench?
maybe over by the Gorgosaurus right there. It'd be a good place to. Yeah. Are you want to sit for a while or
No, it's
just for a minute?
It's your stream.
I think we can hang out for a while if people have questions or something. What time is it? Whew. It's 5 p.m.
We've been about 3 hours.
Yeah, not too bad. Not too bad at all. I'm gonna hear with this Gorgosaurus again.
Tomorrow we are going to be at the Field Museum, or no, the Field House in Vernal.
Yeah, the Utah Fieldhouse Museum in Vernal, Utah. Gonna see a really cool Diplodocus skeleton there. See some cool dinosaurs. We're gonna go out and see the sculpture garden with some very old-fashioned dinosaur sculptures from the 70s.
Okay, that should
be a lot of fun.
Yeah.
And I see a lot of mammals and stuff too. It's gonna be neat. It's gonna be really neat.
Yes, GeoBlizz, you did miss Idaho Falls, but you can check our VOD.
Yeah.
It was a great museum. We had a lot of fun there. The video's really good. Go ahead and check it out.
I would definitely recommend you watch that. It's gonna be. I think you'll be impressed. Yeah, Museum of Idaho was. More than I expected. It was really cool. Yeah. Really cool traveling exhibit that they had there. So yeah. And let's see. And Dark Raven, Arizona Museum. I don't think so, Dark Raven. I've got no plans there. Yeah. Victoria the T-Rex. That sounds like a commercial specimen. I don't know. Much like Stan. got mixed feelings about commercial specimens. But yeah.
When is LACM? I think that should be next Tuesday.
That sounds right. Yeah.
Yeah, I believe
next Tuesday.
I believe that it's Tuesday, Monday or Tuesday. Yeah.
Film the different things in downtown Vernal. Maybe Kamina. Maybe we'll have time
Let's
for
try
that.
and make a point of doing that, and we'll post it on Discord or something.
That would be cool.
Yeah.
Yeah. We could even potentially do a live stream. We'll see. We'll see how we're feeling tomorrow. We've got a lot of driving to do. And great variety in locations. Thank you, GC. We're also going to try and do a stream from Dinosaur National Monument the day after tomorrow.
Yeah,
So
that's going to be a lot of fun.
my encoder was not working when I was there, so I took a bunch of photos and we talked about that, and that was a great time. Should be even cooler being able to show you everything live. I'm very excited about that. Yeah.
We did do the penny press already, Java.
Yes.
And are you going to make it to Cleveland Lloyd?
No, not on this trip road down. It would be really cool, but it's not in the cards for this time.
And GeoBliz 5-star hotels only.
Oh, of course, for her.
Yeah, for me. I'm a spot girl.
I sleep in a tent.
Actually, I mean, I like bring it down to 5. I'm a 6-star girl. 6 stars.
They have to add an extra star when she's staying there.
I'm the extra star.
There you go. Yeah. And restricting on the swing back to Cali? I guess you could say so. I mean...
We're headed south right now before we head back to Cali.
Yeah, we'll be heading east too, I think.
Yeah, just a smidgen.
To Grand Junction, Colorado.
Mm-hmm.
Yeah. But yeah. And, I don't know. I have to go to the bathroom pretty soon here, so I think we might wrap up the stream. We've been going for what, 3 hours?
Yeah, 3 hours.
Okay.
Yeah. This
cool.
has been a great stream, you guys. Thank you all so much for the support today.
Really appreciate it.
I know I've said this before, but I'm going to say it again. We can do this road trip because of the support that you guys give us. It's not free to do this. And
definitely not.
It helps us get into museums, helps us feed ourselves, get some gas in the car, that sort of thing. So we really appreciate you guys and all the support you give to us so that we can stream for you.
Yeah, it's been so much fun sharing this with you, and I'm really glad you can be along for the ride. This has been awesome.
Yeah, it's been really great.
So let me see who else is live right now, and we will do a raid here coming up. Let's see here. CNOT Bush is live. We will raid them. CNOT BUSCH.
Glad you guys enjoyed yourselves. Thanks for all the thanks and nice things you guys are saying in chat.
Seriously, yeah. Can't wait to watch the VOD later and try and look at what everybody was typing in the chat. As I'm trying to give you a tour, I can't be so attentive. I can't look at chat that much.
Right, and I'm only asking the questions. I'm not telling him all the clever stuff you guys are saying.
Yeah.
I'm laughing behind him, and he's not even getting the jokes. But
so it's always a joy to be able to go back and watch the VOD and see what you guys had to say. BUSCH. And we are going to go raid somebody who does a lot of sculpting, but really, really impressive artist. I think you guys are going to like his stuff a lot. So let's go ahead and get ready to do that raid. There we go. So let's show them what a paleontologizing raid looks like, huh?
Yeah.
I really enjoyed this stream. It's so nice to be able to stream the whole museum, too, without my equipment overheating and dying on me.
Oh, yeah, what a pleasure.
Seriously, yeah. This has been really nice. It's been really nice. But yeah, anyway, everybody, I will see you tomorrow?
We'll see you guys tomorrow.
From Vernal, Utah. Until then, everybody, you take care of yourselves, and let's all go say hello to CNOT Bush. All right, see you over there.
Bye, everybody.
All right. There we go. Very cool.
Paleontologizing.